All right. Uh, okay. Hello, everyone. Welcome to the second session of week 3, which is K-means clustering. Today, we will try to cover the practice assignment and few SWI questions we will take. Okay. And before that, I would like to know, is there anyone who has any doubt in week 3 concepts? Okay. So let's take 15 to 20 minutes for to discuss if anyone has any doubts regarding the concept, then we will discuss that and then we will move to the questions.
Sir, one thing, can you clarify on the Warnai region? Once the half spaces are formed, how many Warnai regions are there? So there is one question also on activity question. Can you just clarify the concept once?
Okay.
Yeah.
Okay. Okay, just give me a minute. Okay. Can you tell me the question number? Or so that I would understand that what exactly you want to understand.
Yeah, 1 second. Yeah, it is activity question 3.4, second question.
Okay. 3.4 second question. Okay.
No, in terms of true or false, I don't want. Just if you can tell how many that half spaces, how many are created, and how do we relate with the number of clusters? If you can just explain that.
Okay. Yeah, I understood your question now, I think. Just give me 1 second. I'll share my screen. Okay. So if you see the number of hop spaces, okay, if you see when you have, let's take example directly the questions only. Maybe we have our axis. Let's say we have our mu1 here, okay, cluster center 1 and cluster center 2. If we have two cluster centers, so how many lines or how many separators we need to separate these 2 points?
Only one.
One. Okay. So if we have 3 points, okay, let's say here we have one more mu. So how many separators you would need? Just think it like this. Two, because one more line. Okay, one line between mu1 and mu2. One more line between mu2 and mu3. Okay, like this. So ultimately, you will have the 3 part. Okay, but the maximum line would be 2 only, right?
Correct.
So every time it will be n-1.
Yeah.
I hope you got it.
Okay. Yeah, that I got it. So here, what is half space? When we say half space,
so
what is it?
any line, if it divides it into the 2 parts, no, it is like half space.
Now here there is one. So I will ignore mu3. Now consider mu1 and mu2. So should we consider it as one half space or two half spaces? Separator is one, but there are two parts which are getting created. So in terms of half space, it is two or one?
It is one only.
Acha, one half space. So essentially half space is separator.
It's like a separator only. Line which divides the whole region into 2 parts. Okay.
Hence, if there are two clusters, there will be 2 minus 1 half spaces.
Right.
3 minus 1. Okay, got it. Thank you.
Right. Okay. And anyone has any doubt? I think in the last session, okay, we were talking about multiple things. Mostly the notation part. I saw that many of you were confused about that. So I'll just try to iterate those things. Okay. Or before that, anyone would like to ask anything? Any doubt regarding the concept? Anyone? Okay. I'll just from my side only, like at the and the last session, like many of you were confused at this part. Okay. And yeah, I also didn't give the satisfactory answer because at the last moment I was also in hurry. So yeah. Okay. I'll just briefly summarize this part. Okay. So if you see the convergence part, no. So here, many of you were confused, like whether it should be ZI plus 1 or this should be T plus 1 or something like that. Okay. And here also like the same confusion. Mostly we were confused with most of you were confused with this part. what is this, what is that, something like this, no? Or all of you are okay with this part? Just tell me so that I'll
No,
just discuss.
if you can
Huh?
discuss, please discuss. No.
Oh, okay. 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 So basically, if you see, I'll take. I mean, it's better to take go with example. Then we will try to. I mean, reconnect that example with these formulas. Okay. So what happens? Let's say. Let's talk about the cluster center one. I mean, there are two boxes or clusters. You can say. Okay. Whatever you will say. No. Let's say we have two boxes. Okay. The name of these boxes are like C1 and C2. Okay, just for the clear purpose, I'm writing like this. Okay, C1 and C2. Here also there would be few points. Okay, here also there would be few points. Let's say we have one point here. Okay, and the center of this is here. Okay, so what would it would be? It would be mu1, right? And it would be mu2. I hope all of you are clear about it. This. Okay, and we will assume this as the ith data point. Let's assume that this is xi, nothing but xi, the data point, ith data point. Okay, I have written xi here. Okay, we have written it. So see, as of now, just assume that this is the cluster shape. This is the final, not the final assignment. This is the intermediate step. Okay, so once we finalize that this xi will be either in xc1 or c2, then we can say we will get some shape like this. Either the shape would be something like this, either the shape would be something like this and this, or maybe just the vice versa. Xi may go in another, c2 box also. Okay, or c2 cluster also. Okay, anything can happen here. Okay, so what I would do is that. Let's say in the step, maybe in some step, this xi. Okay, I'll just plot one more. Okay, okay. So this one is our c1, and this one is our c2. See, this is not the final step. Okay, as of now, I have plotted it in such a way that it looks too much away from each other. But okay, here is our point xi. Okay, and here we have another centroid or another cluster. Okay, like this. Okay, so for example, the way I have drawn it, it looks like it is closer to this one. But assume, okay, the distance between here and here, then the distance between here and here. Okay, so just assume that this distance is lesser. Okay, uh, the although by the diagram it doesn't look like that. Okay, this distance let's take L1, and this one let's take L2. I am assuming L2 is less than L1. Okay, for our case. Okay, so then what will happen? Can someone say?
After the intermediate iteration, as part of the final iteration, xi should move to L2, C2 cluster.
Okay, so something like this. Let's take this one xi point here. So now our new shape would be something like this. And just ignore the shape. Do not go with the shape. Okay, somehow just think it like there is one point like which may move like here and okay. So one thing which I can say, one thing we can assume, we can see here is that the if this reassignment is happening. Okay, so at least let's say earlier the distance sum of all the points from here, let's say we had 10 points. Okay, and the distance from here and the sum of all these points, okay, it is nothing but 10 unit. Okay, and here for this one it would be something like, let's say, some unit. Okay, so if we go after from this to this, obviously this x minus mu, the distance of this point from the centroid will decrease, no? Because earlier, now we are taking the lesser distance. Okay. For this x1 is moving to the new cluster where the distance is lesser from the centroid, right? As I mean, this much is clear or not? Anyone just say?
Yes, sir.
Yes.
Okay. Okay. If any case, I mean, if you are getting confused, then we will also take the numbers. Okay. Then maybe so since why I'm asking you, because like no, as of now, like the diagram is not much very clear. Okay. If you see the diagram, we are assuming that L2 is lesser than L1. Okay. So that's why I'm asking it. Okay. So if someone is getting confused, then I can redraw it. Okay. But if you guys are clear, then yeah, we can move to the next step. So obviously this, since L2 is lesser than L1, so obviously the new, after this assignment, the sum of xi minus mu I will be lesser. Okay. I mean the distance from the centroid would be lesser for this point at least. Right? For example, here only like we are assuming that L2 is less than L1. So obviously the distance, let's say if it is a 4 unit, then this would be something like 5 or 6. Okay. So that's why the distance is lesser now. So obviously this point will change. So now let's take this from, just try to interpret this from here. Okay. Or maybe just reconnect these two things. So what this part is saying is that if there is a point, any point xi, and there is the existing cluster center is mu zi, so it is nothing but this c1, so mu zi. Okay, and this zi is not is representing this c1. Okay, zi at tth iteration, so the iteration number was t, and this zi is representing this cluster center. Okay, the first cluster center. So it is nothing but it is this one is representing mu c at tth step. Okay, or maybe a mu zi, and the value of this one is like this only. Yeah. Okay, I hope it is clear to all of you.
Yes, sir.
Yes. Yes.
Yeah.
Yes.
So it is zit is nothing but c1. Okay, zit is representing c1. So what is happening, since what we are saying is that if there is, if there is any centroid from where the distance of this xi is lesser, then just go up to this only. So if the distance from a centroid of any other, centroid of any other cluster is lesser, then it will try to move to that centroid. So in the next step, okay, in the next step, what will happen? This xi will move to this mu2, this c2, right? So
Yes.
this is what, yeah, we are representing here. We are saying that zi after t, in t plus 1 step, it will move to this new centroid. So it is this one is representing this one is representing this one, mu2 t
C2,
of c2.
C2. Yeah.
Yeah. So now we know that overall, the if the distance from the centroid will be lesser, always it will be always lesser, right? Is it clear?
Yeah. Yes.
Now the whole equation, because see earlier, let's say the contribution of all the points are different. Okay, but this point was also contributing, so let's say x unit. Okay, x1 unit, and now since this x we have taken it into this another, we have considered this or maybe we have allotted this xi into another
Cluster.
cluster, yeah, where the distance is lesser. So obviously the distance square will be lesser only. So earlier it was 5 unit, no, now it is 4 unit. So obviously the overall value will decrease. Okay,
Yes.
right?
Yes, sir.
So that's why this sign is there. Okay.
Sir, I have a query, sir.
Yeah, please.
Sir, for example, if we have five points in C1, and each of them is contributing something, and sum is coming out to be 15, for example, and if one point goes away, the value will come down.
Right.
But sir, why are you saying it that value will increase?
So no, the value is coming down only. See, this was the I mean previous step, and now this is the I mean the next step. Okay. So here, what I am saying is that okay. Yeah. So that's why I was thinking that I mean I should go with some other example, or maybe the I mean with some real points only. Okay. Let's take just a minimum number of points. Let's say we have one point here. Okay. Let's say we have one point here, another point here. Okay, these 3 points and this fourth point. Okay, I have to move it to here, this one, no? Okay, from here it would be centroid will be somewhere here. Okay, somewhere here. Okay, just take it like this only. So here is the another point. Okay, and from here also. Okay, something like this. Okay, so what we are seeing, okay, so the initial centroid is somewhere here, right? I mean, at least, yeah, the centroid of this one, let's say, what I am trying to say, okay, I hope I have to take the colors also, okay. What I am saying is that at this step, this is the shape of our cluster 1 and this is the shape of our cluster 2, right? And these are the centroids. Okay, let's say this one, this one, this one, this one. Okay, let's say this is 1 unit, this is 1 unit, this is 1 unit, and this is 2 unit. Okay, just assume it. And here also, like, this is 1 unit and this is 1 unit. Okay, and distance from here to here, let's take less than 2, less than, it should be less than 2 only. So let's take 1.5. Okay, like this. So if I take the x, okay, in this existing case, if I take xi minus mu I at tth step, zit. So okay, zi, okay, yeah,
ZT.
yeah, zt
Of
of I at that point. Okay, something like that. So it is nothing but okay. I'll just ignore this symbol or other thing. So what does it represent? It
Five.
represents the summation of all these things,
Five.
right? 2, 3, 4, 5, right? 5, and also these things like 1 plus 1, 2. Okay, 5 plus 2. So it is representing 7, right? So now what I'm saying is that this point is I mean this point will shift to into another cluster. Okay, here we have cluster 2, right? So in that case, what will happen? So we will get some new shape. Let's use the same color combination. Okay, so again we have C1.
Sir, sorry, sir. One small clarification.
Yeah,
Sir,
yeah, please.
This 2 you have written that last point, no, sir. That is
Yeah.
2 units distance from its centroid in C1 and only
Right.
1.5 in distance.
1.5 from the.
Then it should come to C2 only, no, sir.
Yeah, so that is what I'll do. So there, I mean, this is the tth step, and this is t plus 1th step. Okay.
Before that, the centroids was not as marked. C1 centroid and C2 centroids were different. That's why.
Yeah. So C1 is the cluster number. Okay, just take it like C1 is the cluster number. C2 is the yeah. C1 is cluster 1. C2 is cluster 2, and this is mu1 at tth step. Okay, and this is mu2 at tth step.
Okay, some random tth step. This is
right.
clustering happened.
Right. Okay. So at that point, so I mean this equation, if you see the value of this part, yeah, this part, the value of this part is 7 unit. Okay, this is what I am saying here. Okay. So now after this reassignment, what will happen is that we will get new clusters. Okay. So here, okay, this point will move towards that. No. So let's say this one only. Okay. Now, so what would have happened? Okay, somewhere here we had that point, no, and here and here. Okay, like this. I'm just trying to. What will happen? This centroid will shift somewhere here, right? And I mean, as of now, okay, just to go with that formula only. Okay, because in this one we are not going for the another step of mu. Okay, so what we are doing here, what we are seeing is that just we are comparing with the old mu only. Okay, so here if we see, this was our original centroid. Okay, and here this one was our original centroid, right? So what would be the sum now? And now we have got another shape, something like this. Okay, after this I think, yeah, we will update our centroid also. Like, and as of now I'm just taking the older centroid only. So what will happen here? Now the sum will be something like 1 plus 1 plus 1 3, and here 1 plus 1 2, and plus 1.5, right?
6.5.
So it is 6.5 only. So obviously we can see that yeah, this one is decreasing, right? It will always be lesser, then only reassignment can happen. No, if it is equal to, then also reassignment won't happen. Okay, and if it is greater, then obviously reassignment won't happen, right?
Yeah. So left side is essentially without recalculating the mean. It is only just by
Yeah,
checking.
yeah.
Could be various
We are,
possibilities.
we are talking about, so it is like, see, it is like the some point is there which is not happy with your with its older cluster center. Okay, I mean it is a point, xi is a point which is not happy with its I mean the or current cluster, so it wants to move to some other cluster because the distance from that cluster center is lesser. Okay, in that case obviously this equation will come, right?
Yes.
Okay, so that is what we have tried to show it here. Okay, and the second equation, okay, now I hope you are clear about this thing, right? There is no confusion in these two terms.
Yes, sir.
Yes, sir.
Okay, yeah. So second thing, what I will say is that if we have to take the minimum in, let's say we have n points, okay, something like this. So we have to take, so in these points, if I ask you to take a point, okay, or just to give me that mu value, which one you will choose as a mu value? Okay, I mean you have to choose the mu value in such a way that the distance of all points from there will be minimum. Okay, so it will be always the centroid of all these points, right? Because from there, if we calculate the sum, no, that will be minimum, right?
Yes. Yes, sir.
Okay, so this is what we are saying by this term. Okay, so in any cluster, the point from where all the points, I mean from where all the data points are at the all data point, the sum of the distance of that point from the okay, let me rephrase it.
Chosen centroid.
Yeah, so centroid is the point from where the distance, sum of the distance of all points will be minimum. Okay, this is what this statement says. Okay, if we take any point other than centroid, then sum of distance won't be the that one. I mean it will be greater than the older one. For example, let's take this case only. So this time we have, okay, here if we take any point, no, okay, in this one, in this circle only, let's say if this is not, we are not taking this one, no, somewhere here, no, then obviously the sum of the distance will be, I mean this value will be higher. Okay, if this is I mean if it is at this place, then if we are getting the, I mean average of distance, average I mean average of sum of all the distances, no, so it is 5 unit, no. Then if we move this centroid from this place to any other place, no, in that case it will be always more than 5, right? Just move it.
Yes, sir.
Okay,
Yes, sir. Yes, sir.
yeah, just move it in this side only, like, so in that case this distance will be 1.5, but this distance will be again 1.5 only. Okay, but these distances will, yeah,
3,
yeah,
1.5, 4.5, 6, 7.
yeah, it won't be 1.5 because like it's a diagonal, so it would be like at least more than 1, right? I hope you agreed, no, on this one. So okay, let me take this one. So this is a new one. So now this one we became 1.5 and this one become 0.5. I mean this one is also 1.5. Okay, but the distance of this from here to here and from here to here, okay, it will be obviously more than 1. Okay, it will be nothing but under root of 1 plus 0.5 square, right? So you can think it like 1.5 plus 1 by 3 and it is more than 1. Okay, so and there will be two distance like this, so obviously it will be more than 5. Agree or not?
Agreed, sir. Agreed, sir.
Yeah. Okay, so okay, where we were? Yeah, here. Okay, so this equation is also true. We know that, I mean, the point from where all the distances are minimum, okay, that point will be the centroid of that cluster. Okay.
So only thing is why here argument minimum of
So
vector
argument, yeah,
v is equal
argument.
to x1 plus x2 y on the right hand side. The average of the points is equating to this. I mean that is not
Yeah.
clear.
Okay. Are you aware about this argument function?
Yes, sir. We are trying to minimize the distance. We are trying to find v such that we minimize the distance between xi and v.
Yeah. So if we are writing just min, no, so then it will be like this: the minimum value of this function. Okay, the minimum value of this. Okay, but if we write arg min, no, in that case it will give us the minimum value of this. I mean the minimum value of this to what point of v the minimum value of this will happen.
Correct. That
Okay.
is clear.
So
But
yeah,
why we are writing equal to x1 plus x2 plus dot 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 xn by n? How is that relevant over here?
I think the solution of this is the right hand side. Solution
See.
will be v.
Acha, relevant
ultimately,
points
yeah.
of,
So
okay,
if we
relevant
differentiate the
points of
left hand
x
side,
size,
if we
which,
differentiate
the average of this will be equal to v. Okay.
Yeah. So it's like, see, ultimately how you calculate centroid, like
Right.
this only, no?
Correct.
Mean of all the points. Okay.
Understood.
So that is what you have able to. Yeah. Okay.
So can you say the difference between R mean and mean?
Yeah. So let's say if I'm writing something like this, let's say I'm writing x minus 2. Okay. Okay. Mean of x minus 2 at x equal to, okay, mean of x minus 2. So what would be the, so it will give you the minimum value of this x minus 2 function. Okay. Okay. Or maybe I can say that x is from, let's say, 0 to, okay, I mean just the simple, actually I'm not doing any derivation or anything. Okay, maybe if I'll write it like this, no, x is from 0 to 3. What would be the value of this one? What would be the value of this?
Minus 2, minus 1, 0.
0, 0.
0?
Minus 2. Minus 2 will be the minimum value.
Minus 2, right? So now if I write arg min of x minus 2, what would be the output here?
0.
Here the output will be 0 because here so the output will be that value of x. Okay, arg min of x. Here that value of x at which this value is minimum. Okay, so I mean here we gave you the, I mean the answer was minus 2 only, but here the point where the this value is minus 2. Okay, which is nothing but the, I mean we are asking you the value of x. So we know that, I mean at x equal to 0 it is minimum. So the output will be 0. Okay. Yeah. Okay. So now in the next slide, what we are saying is that see, just by using this concept only. Okay, just by using this one. So what we are saying is that if at t plus 1th iteration, let's say this is our, I mean updated mean, then okay, any point if we take, okay, any point, okay, so that if I mean we calculate the distance from any other point, no, let's say this is not v, I mean do not just get confused with that v. let's say any point in here, let's say this is our centroid. Okay, so what this is our original centroid, so which is nothing but this mu2. Okay, if I change this from any other point, no, so that distance will be more, right? This is what we said just in the last slide, no. So if we just change it from anywhere, if any point is not changing, then in that case, if I take any other distance, no, that will be more, right?
More or equal?
Yeah, more or equal. Yeah, because equal in the case if I take this one only. Okay. I hope this is clear, right? I mean, this is what we said in the last step, last slide.
Yeah.
So again, we are reiterating the same thing. Okay, which is that, I mean, the mean is the point from where the distance of sum of average of the distance of all points are minimum. Okay, so if it is not that, if we are not taking that centroid, then this will be great. The average of the distance will be more. Okay, this is what we have written here. Okay, so now what we are doing is that since we the new this one, what we are saying is that if this point is V is nothing but the older centroid. Okay, in that case also this equation will hold true, right? I mean, did you got it or not?
Yes. Here we are
Yeah.
recalculating the mu. So mu is changing from mu t to mu t plus 1. And the revised distance will be less than or equal to the distance in tth iteration.
Right.
Yeah.
So
Older
again,
centroid.
so again, let's go to this one. So what we are saying is that, let's say tth iteration, this was your centroid. Okay, after then in the t plus 1th iteration, okay, t plus 1 we have already done. So okay, in t plus 1th iteration, we would have our new centroid, right? For these points, it will be something like somewhere between from here to here, right? Centroid will change. I hope it is clear.
Yes, sir.
See, yeah, earlier it was like this. So now since we have these many points only, so centroid will be somewhere here. Okay, our new centroid, and the distance of all the average of okay, the distance of all point from here will be lesser than this red point. So the distance of all point from green point will be lesser than the distance from the red point, right?
Sir.
Yeah. So this is what I mean, this equation tries to prove. Okay.
Yes, sir.
Yeah. And I hope now, I mean, no one has any doubt related to this sign convention. Okay. So here it is representing your mu at t plus 1th step of, let's say, this one. Maybe, I mean, the updated updated cluster center.
Cluster.
Okay. Yeah. Okay. Yeah. Now let's go to the next slide. Okay. So here what we are saying is that ultimately this is what our objective function was, no? I mean, it is representing our objective function only. So we can see that after each step, no, our objective function will decrease only, right? Our objective function will decrease only after each step. So which simply means that since our objective function is decreasing, then it means that it is trying to move towards the minima. Okay, at least it is trying to move towards the, I mean, moves in downward action. Okay, if our objective function is continuously decreasing, okay, or at least decreasing, then it means that we are moving toward the optimal solution. And also we know that there are limited number of possible partition, right, which was k to the power n. Okay, so can we, I mean, using these two logic, can we say that, I mean, ultimately we will reach to the, I mean, ultimately we are trying to converge the
Yes, sir. Maximum
Right.
at k to the power of nth iteration, it will be converged.
I hope it is clear to all of you, right?
Yes,
Sir.
sir.
Sir, here in
Yeah.
this second line, f of z1 t plus 1, z2 t plus 1. So when we say z, it is nothing but the xi minus mu of t plus 1 for z.
Z. No. Z is representing the, see, f is a function. So what we are saying is the function of new cluster new cluster index. Okay. So every point, so this Z1 t plus 1 is representing the cluster of the first.
T plus 1 is the
cluster.
iteration, z1 is the cluster.
Yeah. Z1 is the Z1 is the cluster number of this one, first point.
Right.
X1.
Okay. Yeah, X1, right.
So when we say function f, that function is nothing but the distance of the data point to the cluster centroid.
Yeah. No? So this complete whole sentence is representing this one.
Correct, right? And the right side of the same function, that is representing the iteration.
Yeah, right.
Right. So there is nothing, no function for the middle one, that is the intermediate step.
Yeah. So here, there is no function for the middle step.
Okay.
Yeah. Okay. So middle step is showing that then reassignment is happening. Okay. I mean, in this case, it is happening. Okay. So any confusion or anything or any doubt as of now? All right. Then let's move to the practice assignment. Then we will take a few questions also. Okay. So ultimately, in this chapter, what we learned, just I'll briefly recall. Okay, 3 parts: how k-means works. Then we learned smart initialization. Okay, I can say it like this. Smart initialization, which was k-mean plus plus, just to avoid some local optima case. Okay, or reduce our number of steps. Okay, we use this one. Then third part was about how to choose the k values, right? Okay, so these 3 parts were there in this chapter. Okay,
And Bornai region also.
Warnai region also. Okay,
Nature of clusters.
Nature of clusters. Okay, so that was also there. Okay, anything else? Okay, no. Okay, just let's move to the practice assignment then. I'll just open it.
Sir, to summarize, why don't we really make a fast scan of all the slides within 5 minutes?
Okay. I'll just. Okay. Here, if you see, see.
Yeah, fast is.
Yeah. Okay. So basically, we understood that first we have to decide the k values. Okay, how many k we have to work. Okay. After this, we will assign. It's okay. Whether my audio is getting. I'm getting echo. Is it for me only, or for all of you?
Problem, sir.
Yeah. Sorry.
No, slight echo was there, but not very prominent.
Okay. Now I think it is clear. Okay, maybe someone has kept their phone. They will be on mute. They have not kept their phone on mute. Okay, so after this, what we said is that first we have to decide the k values. Okay, then we have to assign each. Okay, and let's say once we plan that we have to go with 3 k values, then we randomly selected 3 data points as our initial centroid. Okay, and then based on this centroid, we will assign each data point to the different centroid. Okay, once we did it, so how we will do it? Based on the distance from each point with this cluster mean. Okay, then based on the minimum distance, we will assign each data point to these 3 cluster centers. Then again we will calculate cluster mean. Okay, and based on that, we will calculate new cluster. we will calculate, we will see whether any reassignment will happen or not. Okay, in case if any reassignment will happen, no, then we will again repeat this step 2 and 3. Okay, and this will make more sense once we discuss the questions. Okay, so yeah, these were the step of k-means clustering. Okay, and then what we learned is that, I mean, we just tried to represent it in the formal way. Okay, so these were our data points. So, and these are the cluster indicators which show that, I mean, x1 is x1, I mean, what cluster is I mean, x1 fall in which cluster. Okay, so this was, I mean, we represent it using z1t. Okay, and t represent the number, iteration number. Okay, so same thing, I mean, I mean, here what would be the cluster center? It will be nothing but the average of all the data points inside that cluster. Okay, so always our objective is to minimize this value, right? So okay, then we learned about k-mean plus plus. So what we do here is that first point, I mean, so I mean, here it is nothing but k-mean plus plus is nothing but space some step for initialization and then k-mean only. Okay, take it like k-mean plus plus equal to smart initialization plus k-mean algorithm. Okay, it is like this. So what we do here is that for initialization, we randomly choose our first cluster mean, and based on the distance, we assign weightage. Okay, and based on that weightage, we second other clusters. Okay, this is what we do in k-mean plus plus. Okay, so okay, but now the next question comes like how to choose the k values. We saw no at the beginning only, like k value number, how many k values should be there. So that we understood that it should neither be too I mean, see, ideally we should try to take a minimum number of k values, but we know that, I mean, once we increase the k values, then objective function will decrease. Okay, so somehow we will try to do a trade-off between these two things. Okay, so that's why we have introduced one new term, penalty. Okay, so which is nothing but pk here. Okay, and here k is I mean, we have seen that, I mean, we had aic and bic, and their different formulas are there, and where I think two parameters are there. So one is the parameter k, so which is the, I mean, one we have one parameter which is k, which is represent the number of centroid, okay, or number of clusters, and second part was this one, log likelihood, I mean, yeah, likelihood function. Okay, so basically this function, what is the job of this function? No, aic and bc, the job of this function is to give you the, I mean, to avoid overfitting, so that, I mean, this way what will happen is that once you will try to increase this k value, no, then it will put penalty to your objective function. Okay, this way you will reach at some optimum value of this objective function. Okay, and this will give you the optimum k values. Okay, so this is what we learned here. And after this, yeah, we saw one more method, which was elbow method, which says that, I mean, so once your graph, I mean, if you draw the graph of between objective function versus your k values, no, it will be something like this. The point from where the slope is maximum, no, okay, you will see some elbow shape, no. See, I have drawn it like this, but the shape won't be like this because k value is discrete, right? K after 1, it will be 2 only. So it will be something like this only. I mean, at least, yeah. Okay, I mean, we can't draw a continuous line. Okay, or a curve. Okay, so not the continuous line, yes, curve only. Okay, so you will see the point where the maximum bend is happening, no, that point will be considered as elbow. Okay, but ultimately it completely depends on the domain knowledge. Okay, okay, based on your domain knowledge and result, you have to choose those k values which is making more sense. Okay, so that is there. And after this, we just tried to cover the like nature of clusters. Okay, and yeah, then we just give the brief idea. We proved that whether the algorithm will converge. Okay, so this is what we learned in this chapter. I hope it is. I hope I give you the brief intro of this chapter, right? Okay.
Yes, sir.
Yeah. Okay, let's see this one. Okay. So just see the question. So first question says, which of the following sequence? Okay, I won't discuss too many things. Okay, you have to give the answers. Okay, if help is needed, then I'll just help you.
So yesterday, the TA session, they had discussed this entire.
Okay, they have discussed this.
Yeah,
Okay.
they discussed, but I don't know how many of them attended who are attending now.
Okay.
If it is going to benefit them, then you can run through it.
Yeah, maximum 15 minutes. Okay, 10 to 15 minutes. I'll try to cover it. Okay. So, which of the following sequence is correct for K-means algorithm? Can someone say? Okay, I mean, okay, answer is also visible. Yeah.
First, we'll specify the number of clusters.
Okay.
K will be specified.
Okay, it would be better if someone says that, I mean, who has not attended the previous session. So if they says, okay. Anyone? Okay, we have, okay. That request is on. Anyone else would like to say? What would be the correct sequence?
So first,
So first specify the number of clusters
Okay.
and then assign cluster centers randomly. Assign each data points to the nearest cluster centers.
Okay.
And then recompute cluster centers and then reassign each point to the nearest cluster centers.
Okay. Yeah, sounds good. Okay. Let's move to the question number 2. So it says that if if f of z1 t represents the value of objective function in iteration t of Lloyd's algorithm, then which of the following is true? At t plus 1th, it will obviously, if we are going for t plus 1th step, then obviously this value will decrease only. Right? I hope it makes sense.
So it's hard clustering.
Yeah.
So it has to decrease.
Right. Okay. So third question said, if mu and mu2 are means of two clusters in K-means, then the boundary between the two clusters will be
So it would
obviously
be the mean.
Yeah. Perpendicular to the line joining mu and mu2, and at the point mu1 plus mu2 by 2. Okay.
And this is what will form the Voronoi region.
Right. Exactly. Okay. So see, I am just going fast. If anyone has any doubt, no, just I mean, they can stop me at that point. Okay. So So fourth questions is is an interesting question. Okay. Choose the following data points. Assume K-means is run on these points with K equal to 2. Which of the following are expected to be cluster formed out of K-means? What do you think? So these are the data points, and after I mean, just by putting K equal to 2, you set K equal to 2, then which of the following diagram you can see as your answer? Can anyone say? Actually, two diagrams are only there, right?
Last one, second one.
Last one. Okay. Why not first one? Why not first? Can anyone
because K means divide the data linearly, matlab bisect.
Okay. So here also, like, it is possible, no? Here also, if I plot like this, no, I mean, if our half space is, I mean, this is our half space, no? Then here is one cluster and here is another cluster.
But the distance from mean is
That
distance from
mean.
So distance from mean, the mean from if we divide it like this, the mean will be at the center of the line.
Yeah, here.
And the extreme point will be more. The extreme point on this line will be more than the point opposite to it.
Okay, so what is the issue? Like here, this is 3. So 2 unit from here, 2 unit from here. Okay, here also this is 2 unit. Here also this is 2 unit. Right? Any point? I mean, if
same cluster.
Yeah,
middle points will be in the same cluster.
Middle point will be in the same cluster. So here it is like this, no?
Yeah,
So all the points like so this will be our cluster center, no? In this case, and in this case, this one will be our cluster center. So all the points are within 2 units.
but the middle ones are closer.
Middle ones, which one? Okay.
The two middle.
Okay, I'll just delete it like this. Okay. So yeah, just tell me, what did you say?
If you take like this option where the top and bottom, right? If you
Hmm.
take it by the mean one by one, it won't be feasible because
Why?
the middle two means will be in the same cluster.
Middle 2 means will be in the same cluster.
Yeah, the
Why?
middle two, because
Why
they
it
are
should be in the same cluster?
because they're closer to each other, no, than any
So
other from the
okay,
left and right also. If you take two distance each, there'll be only
yeah.
one cluster then.
So see, again, if I take this also, no, let's say in this shape. So ultimately we have this one. Okay. For example, I mean here if you see that here in the questions also, like you can see. Okay. I'll just give you take your example only here. Okay. In this case also, let's say if I am taking like this, no. Here in this case, our centroid will be here and here, right?
Yes, yes.
Yeah. In this case, if you see that this distance would be, I think, yeah, more than, more than, I think, yeah, less than 2 for sure. Okay. But see, again, what is our question here? Okay. Let's go to that question. Okay. Okay. I choose this one. Okay. Okay. So what we are saying that assume K mean is run on these points with K equal to 2. Which of the following are expected to be the cluster formed out of k-means? So do you think, I mean, this one, I mean, k-means algorithm won't give this one? Only this one it will give?
No, I'm not so sure.
It might give the first one also, sir. It's confusing. Actually, there is in the practice assignment solution PDF, there is one more option which says that it depends on the cluster initializations and the centroid, initial centroids. That option is not here in this assignment 3.
Okay. Okay.
Whereas
So,
the
so
solution
actually, it
PDF,
does
they're
depend on
giving
the
this.
initialization, right? It does depend on the
Actually, it depends on
initialization,
multiple
isn't it?
things. I'll say here. In this case, no, since we already, I mean, we have fixed value of these things, no? So it depends
If
on,
there is no y value given, if there is no y, like we don't know the exact distance, then like we can get the both answers
yeah.
depending on the
So, yeah,
initialization. Here we know the
yeah.
distance, so it has to be the second one.
Here we have the distance, so I mean it should be certain. So see, again, one variable is there, no, we have not mentioned the initial centroids. Okay, so it depends on the initial centroids. For example, if I take any centroids, I mean if we take initial centroids, one centroid on this line, okay, and another centroid on this line, no, then you will end up with this shape. Okay, but if we take any random centroid, okay,
Excuse me,
other
sir.
than these two,
Excuse me,
yeah.
sir. In the question, they are saying that expected clusters. They are giving that, assuming that this is the cluster.
Okay, which of the following are expected to be the cluster formed out of k-means? Okay, so
Right.
they are what they are saying that these are the data points, and we I mean they have assumed that they are k value is 2. So
Right.
which of the following cluster center? I mean which of the following cluster? Yeah, final output can be.
So, sir,
Okay.
if in the first option, if they are assuming that this is cluster 1 and 2, the centroid will be fixed for each of them, na?
Yeah. So see, what we are asking is that these are the data points. These are the k values. So what can be the output of k-means algorithm?
It will look
This is
for
what.
linear combination.
So, sir, if that's the case, the let's assume the centroid for the first purple one is at the center. So the point exactly opposite to it,
Okay.
exactly opposite to it, will be closer to it. Should be in this purple section only, right?
Okay. So see, I mean, you have to pick two cluster centers, no, not only one.
Okay.
At the beginning, you have to take two cluster center. So one is this one we are assuming, and second we are assuming as this one. Okay. Then what will happen? So all the points which is closer to this one will fall into this one, and the points which are closer to this one, it will fall into these clusters. Okay. Yeah. But if we take any other cluster center, no, then in that case we will get this shape. Okay. In that case we will get this shape. So the answer would be that it depends on the initial. It depends on the centroids. Basically, in this type of shape, no, it depends on three factors. First factor is this one. The distance between 2 points here and here. Okay. Second is this one, distance between these points also. The distance between these two lines. Okay. And third would be the how many data points we have. Okay, how many data points we have. Okay, in these three type of cases, here we have already, this value is fixed, this value is fixed, and okay, one more thing, this initial centroids also. Okay, so here centroid is fixed, no, these three things are fixed, but only the centroid part is not given. So it will depend on that part, centroid. Okay, so here in this question we can say is that it depends on the centroid values. Okay, initial centroid. Okay, both answer can be true. Okay, in case if we would have the enough time, no, then we will draw a graph. We will write code and we will see how it changes. Okay.
Yes.
Or how by changing centroid value and other thing, our answer changes. Okay.
Sir, there was one such question in previous papers also. So
okay.
So can I share it with you?
Yeah.
So let me search it. I'll just share it with you.
Okay. Okay. So that is the. So anyways, I'll just write a code. Okay, and I'll demonstrate it. Okay, how it changes, how we get different shapes. Okay, by playing with all these things. So by playing this distance between these 2 points, playing with these lines or distance between these 2 lines, and also by changing the number of data points and initial centroids. Okay, just by changing with
Sir, by looking these two picture, we can say it is second one, because if we look in the from objective function perspective, if we say always the centroid is the mean of the data points, right?
So always it will be
the second picture. The mean will be the average of this yellow data point, and for another cluster it will be pink data point, average of this pink data point. So if we see the distance from the centroid, the sum of the distance of the centroid, it will be minimum for the second picture compared to first picture.
So see, what question is asking is that if you give this as this data point as input and k value as 2, then what will happen? Okay, so we can so based on the k initial, so since we know that k-mean algorithm randomly select initial centroids. Okay, in case if k-means algorithm select these 2 points as initial centroids, no, in that case k-means will end up with this shape. Okay, but if k-means algorithm randomly selects any data point, any 2 data points other than these 2, no, then we will get this shape. Okay, you can just think it like this. See how the k-means step works. First you randomly select 2 centroids, no, let's assume that this case only. Okay, so in any other case, no, you will get this shape. Okay, let's assume that k-means algorithm. Okay, there are different possibilities. So in one of the possibilities, k-mean algorithm selected these 2 points as initial centroids. So what will happen? This point will be purple only. It is closer to this one. This one is also closer to this one. This one is also closer to this one only. Okay, up to, so here since we know that distance is 1.5, right?
Yes.
So all the point, and here we know that this is up to 2. Right. So all the point which is up to 1.5, we do not have to worry. Okay. Because up to 1.5, this will fall into this shape only. And if some point is more than 1.5, no? Okay. More than 1.5, in that case, see, from the distance from here and distance from here, it will be always lesser, no? From here only, no?
Yes.
Yeah. So it will fall into this.
That point I understood, but based on the question, I thought second answer is correct.
Yeah. So that, so what that you are thinking, so see, that is so you can think it like, yeah, this will be your global optima case, but here based on your initial centroids it we can fall to the local optima value also, right?
Yes, yes.
Yeah, so this
Sir,
can you can
Sir, I
yeah,
have shared the paper, sir. You can check, please.
okay.
So search for MLT.
MLT only, okay. Okay,
Scroll down.
I think, yeah,
So this one.
this one,
Right, sir.
okay. Okay, yeah, similar to this one we have also taken, I think exactly this one only, like, okay, we have taken in this one, okay, in our slides, our practice, our SWI question, okay. I'll discuss it over there, okay. Okay, is it fine? Okay, here only, like, see, this one is there, no?
Yes, sir. Yes, sir.
Yeah, I'll discuss it there. Okay, okay, let's move to the other question. Okay, so I'll discuss this question, later also, like, if time permits, no, I'll take this question again. Okay, I'll write code and I'll see, I'll demonstrate like how thing changes. Okay, after this step. Okay, so in the initial in the initialization step of k-mean plus plus, the square distance from the closest mean for 5 points are like this. Okay, so which one point would be chosen? So we know that, it is proportional to the square of distance. So obviously the from where the distance is maximum. So okay, so this is the this one is the point, right? 89. So okay, so x3 will be chosen, so which is nothing but x1, x2 and x3 only. So x3 will be chosen with the highest probability, but we are not sure whether this point will be definitely be chosen. So why we are saying this? Can someone say?
Sir, because the points are chosen based on probability and not their exact distances.
Yeah, right. So here, if you see, although these are the fixed values, so and we know that, based on the distance, so the probability will be higher. But again, it is only probability. It is not deterministic value. Okay, so that's why, although the distance is maximum here, but again, it's just a probability only. Okay, yeah. So that's why we have written the second point. Okay, second part of the sentence. Yeah, can someone? Whether someone is trying to ask something or?
Yes, sir. I just have a basic query here. I could not understand the probability concept on choosing the clusters. What exactly we need to use probability for?
Okay, so in general, for the scope of our course, you just take it like, yeah, if most of the time what we will ask, no, if we ask you the initialization step, no, based on the distance, you can select the second point as a cluster center. Okay, based on the highest distance. But there would be cases, okay, when your, maybe when your density changes, okay, or the shape of the different cluster is different. Okay, based on the shape of clusters and density of points, okay, this distance formula cannot work. So in those cases, this probability part comes into the picture. Okay, for example, I'll draw one diagram. Okay, let's say we have points like this. Okay, normally just by observation you can see that we have two clusters. Okay, one cluster like this and second cluster is like this, right? So but what will happen when you will use k-means clustering algorithm? So, and if we assume this one as the our k-mean plus plus, if you use this one as a k-mean plus plus for initial centroids, okay, then we will get some shape like this only, no? I'll just try to draw it, shape like this. Okay, let me draw it like this. Okay, or something like this, right? Yeah, so that's why what we do, what we say is that our initial centroid should not be, it should be deterministic only. It should be probabilistic based model only. Okay, if we, our initial, first centroid is this, no, then by default k-mean plus plus k-mean will try to take the second centroid somewhere here, right? And in that case, we'll end up with shape like this. Okay, which is not the ideal shape which we want. Okay. So that's why what we say that even though the distance is maximum, still it is a probability of select. Still we are putting the probability part. Okay. So we know that to make any. So we are saying that it is proportional to the distance. So based on some constant, no, the constant which we will multiply here. Okay, we have put in this part as a variable part. So that based on this point, no, we can make the adjustment here. So that we may end up with this shape. We may end up with this shape, something like this. Okay. So that's why we say that it's better to. So that's why in the formula, no, in K means they have taken this probabilistic only. They have taken this probabilistic approach, not the deterministic approach. Okay.
But how do we use probability here? Like, what exactly we'll do so that we get the initials based on probability?
So
say in this case.
Yeah. So in this case, just take it like, see, based on the distance. Okay. Let's say some point. Okay. Here. Let's say there are 4 unit of distance. Here there is a 3 unit of distance. Then based on distance, no, let's say 4 and 3. Okay. So based on distance, let's say here the possibility of selecting this point as a centroid, no, it is 4/7, and for this point it is 3/7. Okay. So like this. So there, you will assign probability to each data point, and based on that probability, no, you will select them. Okay. So that is there. Okay. And sometime you will see that it is not just distance, it is distance square also. 4 square plus 3 square. 4 square upon 4 square plus 3 square. Again here 3 square upon 3 square plus 7 square. Something like this. Okay. Yeah. For simplification, I've written into just to the one form. Okay. So it is proportional to the proportional to the square of the distance actually. Okay. Okay. Let's move to the question number 6, which says that with respect to Lloyd's algorithm, choose the correct statement. The partition configuration cannot repeat themselves. So yeah, this is true. Okay. If any point will only move when the distance of that point is lesser from any other centroid. Okay. So if it is lesser, then obviously it cannot move to the same centroid. Okay. The same configuration can't be there. Same configuration can't repeat. Okay. So that is there. Then second question says after doing the reassignment, we might get the same partition configuration again. Okay. So that is not true. I said. Okay. Objective function after making reassignment is strictly reduces. So that we saw in the convergence derivation is that objective function will strictly decrease. Okay. Fourth option says objective function after making the reassignment may increase. So that is not true. A change of value of objective function indicate that partition configuration has changed. Yeah. So whenever objective function changes, then it simply means that configuration has changed. Right. So last point is for partitioning n data point across k partition, Lloyd's algorithm takes k to the power n iteration to converge. No, k to the power n is the maximum number of iterations. Okay, maximum number of combinations. Okay, or maximum number of iteration possible. Okay, so that is there. Okay, so 7 questions say for 1000 data points out of k equal to 1, 10 and 100, what value of k is likely to result in the maximum value of the objective function? So can someone say like what would be the answer for this one?
So if it's k equals 1, then it would be maximum.
Right, because we know that objective function decreases when we increase the k values, right? So yeah, it will be maximum at k equal to 1. Okay, and once it is k equal to 100, then this will be 0.
Sir,
right?
Can you please explain the 7th question once more?
Okay, so in the 7th question, what we say is that let's say you have these many data points. Okay. Okay, I think we have drawn here only, no? So just take this one only. So let's say what we are saying is that this was the distance, no? This was the actually when k equals to 2, no? This was our value. X minus mu z square. Okay. Okay. Here only like we have taken just 5 square plus 7 square. It will be.
X minus mu z square formula. I don't catch up that point.
Okay. So it is nothing but representing the any point and the distance from its mean.
Okay. So.
Okay. Yeah. Distance from its mean. Okay. So what I am saying is that let's take this one only, or maybe okay. Anyway, just take this point only. So what will happen is that here is another point. Here is one more point. Okay. Let's go with this much point only. So in this case, let's say if k equal to 1. Okay.
Yes.
K equal to 1. Okay. So this will be your cluster. K equal to 1. In this point, what would be the centroid? So obviously it will be sum of all the point by 3 to 5. Okay. Let's say centroid is somewhere here only. Okay. I'm assuming the centroid is here only. Okay. And
centroid is the mean here, right?
Yeah. Centroid is the mean. Okay. I'm assuming some random value here. 3, 1, okay, 1.5 and 2. So what would be the value of this function? It will be nothing but 3 plus 2 plus, okay, although here we had a square. Okay, I'll just ignore that also. Okay, 3 plus 2 plus 1, 6, 7.5. Upon how many values we had? How many? 1, 2, 3, and 4. Okay, I think yeah, 3, 4, 5 actually. Okay. Anyway, okay, let's take this one. Okay, so this was our initial centroid. Okay, I mean initial value of this equation. Okay, so once we have two centroids, in that case, what will happen? Okay, let's say in second step, what will happen is that these 2 points will fall into one shape. Okay, and second, this will be the next. It got splitted like this. Okay, in this case, this will be our centroid, and here in the case, this will be centroid. So what would be the distance? Here it is, let's say, how many unit? 1 unit, right? 1 plus 1. So what is the value? 1 plus 1, 2. And let's sum this one only from here also. Like how many? So earlier the distance between these 2 points were 2 only. So now the distance from both sides, like it will be 1 and 1, right? I hope it is clear.
Yes, sir, it's clear.
Yeah.
But I can get that. How can you divide this by? This has 3 points, and another one has 2 points only.
Yeah. So this is what we are saying, that we are saying that k value is increasing. Earlier k value was 1, so this shape we had. Now k value is 2. So in that case, what will happen? We have to take two different centers. Okay, any center. So for example,
we are differentiating in 2 centers, but why the distance is 1 here? I mean, between 2 points, our distance is 1, right?
Okay, between 2 points. So see, between these 2 points, the distance is 2 only. Okay, but we based on these 2 points, there will be new centroid, right?
Yes.
So this is what this is our new centroid for these 2 points. Okay, or for this cluster center.
Okay.
Okay, so the distance from here will be 1 and 1.
So
right?
Previously it was 2, right?
Yeah, the distance between these 2 points were 2 only.
Okay.
Yeah.
And
So that's
one had distance. Another point had distance between 1 and 1, right?
so now we so based on these 2 points. So this is mu2 is not a point actually. Okay, do not get confused with this.
Mu1 had the equals mu1 had distance 1, right?
Mu1 has distance 1. Okay, yeah.
This.
So see here, this is point or data point only. But what we are assuming is that our cluster center. So obviously, based on the data points, this is also cluster center. Okay. I hope you got it or not.
Yes, sir, I got it.
Yeah, 3 to 1, 1.5 and for this point it will be 0.
Yes, sir.
Okay. So that's why it was 7.5 by 5. And in this case, now we have increased this k value, no? Then we got shape like this. So obviously in this case, so now again, our centroid for this cluster is, overlapping with this point. So again, the distance 1, 1. And so obviously 1 plus 1, 2. And for this point 0, 2 plus 0 by 3. And in this case, 1 plus 1 by 2. 2. Yes. Okay. So in this case, if you see, it is nothing but a 0.66 plus 1. So it is 1.66 only, right? It is so.
I have a one silly question. Why we are differentiating in this or when k equals 2, we are differentiating in 3 points and 2 points. Here, how can
Yeah.
we decide that one have 3 point and another one have
So
2
see, okay, I'll tell you. So here, the way these points are there, no, based on the distance, you will get some shape. Okay, does not matter. I mean, you can. I mean, the way. I mean, see, K-means algorithm has steps, and based on that step, it may also happen, or based on that step, okay, it may happen that here we have 2 points and here we have 3 points.
Yes.
Okay, that is also possible. But in that case also, this, if you see the finally, the objective function will decrease only.
Okay, sir, I got the point. The distance have to be minimum.
Yeah, yeah. Again, you see, no, I mean, here, I mean, just all points we are calculating from the, I mean, this centroid. Now this point has a new centroid, okay, which will be always, I mean, which will always be closer to this, okay, than the older circle. Okay, I mean, for these points, so the cluster center will move somewhere here only. And in this case, in this type of separation, we saw that this cluster will move here, from here to here. So obviously, distance will decrease. And for these 2 points also, like the cluster center, earlier the cluster center was here, but now it will be here. Okay.
Yes.
So yeah, that's the logic. Okay. That's why, and eighth question said for 100 data points, if k equal to 100, so what will be the value of objective function? So that will be 0, because in that case, every point will have their own cluster center. I hope it is clear.
Sir,
Yeah.
could you please show that slide again in which you have scribbled something? Yeah. So what was this 7.5 by 5?
Okay. So I am taking the average. Okay. Here, what we are saying is the distance of all the points, like the distance of all points from here, the centroid. Okay. So first point, the distance of this point from here is 3, and the distance from here is 2, and distance from here is 1.5, and distance from here is 1. Okay. And
So
this
you are
point.
taking,
Yeah.
so you are taking average.
Right. Right.
Sir,
Yeah.
isn't that the you are taking average so that you can find the new centroid, right?
Yeah. So see, again here, multiple thing can be there. Yeah. So that is the one case for where, I mean, you will get this new centroid. Okay.
Wait a second, sir.
Yeah. Yeah. Okay. So again, I'll just directly take it from the formula. Okay. Here, if you see, actually, I am not using the exact thing here. I'll show you this one. Okay. So ultimately, our objective function is this one. Okay. Xi minus mu I square. Okay. So which is nothing but this one. Okay. Okay. Here. Okay. Xi minus mu I square. Okay. Let's. I mean, I was just ignoring this square part, so that, I mean, just to do the easy calculation. So here, if we see the objective function exactly, no, it will be something like this. It won't be 7.5 by 5. It would be like this. Okay. Here, for distance from here to here, it is 1 unit, 1 square. Here to here, 2 square. Here to here, 3 square. And here to here, 1.5 square. Okay. I hope you got it now.
Yes,
Yeah.
sir.
Yeah. So that will be there. Okay. But again, if you see that if we are reducing the distance, no, so this is also a function of distance. So that's why, I mean, obviously average distance will decrease. Okay.
Sir.
Yeah.
Okay. After, so we are this is the average, right? This is the average, and after calculating the average, we will reassign the centroid, right?
Okay. Okay. Actually, not average. Actually, you have to calculate this value. Okay. If you see, no, you had to calculate this x minus mu square.
Sir, what is the purpose of all this
Okay.
calculating?
Purpose of all these things is to that whether is there any point like which will reassign or not. Okay. Or maybe you can think it like, yeah, whether this one is better or another one is better. So we know that, I mean, every time if we increase this k value, no, this will, I mean, the shape will be better. Okay. Or I think the objective function value will be lesser. Okay. So that is one thing. Second thing is that which shape is better. For example, in this case, I mean, there is possibility like this also, and there is also possibility like this, where 2 point is here and another point like this, right? So whether this shape is optimal or this shape is optimal, that is also possible, no? In this case, your objective function will tell you that whether this one is better or this one is better, right?
All right, sir.
Yeah,
So we are calculating the object value of objective function.
right. Here, I
And
mean, see, yeah. Okay, tell me.
okay, sir, got it.
Okay, yeah. So what
So,
I
sir, here,
yeah,
if k is equal to 5, sir, then the value still decreases from k is
yeah.
equal to 1.
Yeah. So if k equal to 1 is this one, no? K equal to, if the k equal to 5, no, then what will happen? Shape will be like this. Okay. I mean, we would have 5 clusters. Okay. Then so obviously this will be the cluster center also. So the distance from I mean the distance of this point from its cluster center, okay, it will be 0 only. So 0 plus 0 plus 0 plus 0. Okay. So like this.
Yes. Okay.
Yeah. So see, many times what I have done in this calculation is that, so this calculation just for demonstration purpose. Okay. So what I have done here is that I just try to show it in terms of distance function, and I have not taken the squared part. Okay. Just ignore those things, so that I'm just to give you the idea. Okay. How things are changing. Okay. Or how some values are decreasing. Okay. So ultimately what we do in real life is that I mean what K-means do is that it tries to move towards the optimum value of objective function, which is nothing but this one. Okay, here also I think, yeah, we would have written. Okay, so yeah, this one is your this is your objective function. Okay, so your job is to minimize this value. Okay, minimize the norm of, I mean, yeah, xi minus minimize the length of any point from its centroid. Okay, and since we have multiple centroids, no, so that's why we have written sigma.
Yes, sir.
Okay.
So and here the number of partitions in that example, how maximum how many we can have?
Okay, maximum how many partition we can have? Is it what you are
Yes.
asking?
Yes,
okay.
In the example for k is equal to this one, which you are writing.
Okay.
Previously.
Here.
Yeah. Maximum partitions.
Okay, so see, here we had 5 points. Okay, so a minimum number of k value is 1, right? So this bigger circle, so all point falls into the, I mean, this single cluster. So second part, I mean, the maximum number of cluster can be 5 here in this case. So that what will happen in that case? So all point will be in the different cluster. Okay, I mean, or maybe you can say that all point has its own cluster. Okay, or
yes.
So in this case, if you see the distance of any point from its cluster mean, it will be 0 only. Because why? So since one point is there, so that point itself will be the cluster center also. I hope it is clear.
Yes, sir.
Yeah. So the distance of this point from its cluster is 0. The distance of this point from its own cluster is 0 only. So it would be like something like 0 plus 0 plus 0 plus 0. Okay. I think one more 0.
Yes.
Yeah. So that will be there. Anyone has any doubt till now?
No, sir.
Okay. Yeah, here it is. So that's why you saw that, I mean, k equal to 100, your k at k equal to 100, your the objective function value is 0. So ultimately what we are saying is that, see, what we are saying is that in a class, just to, I mean, summarize these last two questions. So in a class, let's say you have 100 students. So how many group you can form?
100.
Yeah, you can form 100 group. Okay, so in that case, okay, in that case what will happen? Okay, so a minimum number of group is 1. So you will assume that all the students are from the same class, so that is the minimum number of group, and maximum number of group is 100. So in this case, if I take it the distance, let's say all the peoples are from I mean, we have, let's say, okay, let's take this. Okay, let's say we are taking here, okay, when we have just one bigger group, okay, I mean we have taken whole class in a one room, no, then the distance of all the student, I mean we have to take the distance of all students from its own center. Okay, so somewhere from here, okay, we have to calculate the distance. But in case if we create 100 groups, you know, in that, so what will happen, then in each group there will be one person only. So if I ask you to calculate the distance of that person from him or I mean the distance of that person from his own centroid, I mean the group center, no, it will be 0. Or in terms of data points, so the center distance of this point from centroid of this cluster, no, that will be 0 only, because both will overlap, right?
Yes, it's have only 1 point, so
Yeah. So that's why. So a I mean centroid is nothing but the mean of all the points. So since 1 point, so mean will be that point only.
Yes, cluster mean and the point are same. Both are same. So
Right.
this will be 0.
Okay. In the next question, it says like in K-means algorithm, all cluster initialization lead to the same result. Is it true? Just in the question number 4, yeah. Just in the question number 4, we saw
Sir,
that.
it
I mean,
depends.
yeah. So yeah, it depends on the initialization. In the last question only, like we saw, I mean, the question number 4 only, like we saw that. I mean, we will get the different step based on the initialization. So second question says one initialization might get stuck in local minima while another may lead to global minima. So that is true. Okay. Third question says one initialization may converge while another may not. So that can be also possible. Okay. So what will happen? Okay. I mean,
Sir?
obviously, no. Yeah.
Sir, no, it cannot. No, sir.
Yeah.
Convergence is the basics of our
Yeah.
this entire chapter.
Right. It will converge for sure. But yeah, whether it's a local minima or a global minima, it depends. Okay. So that is
how
true.
do you find that that one nation might get stuck in local minimum?
Okay, so see in this case also, what will happen is that let's say your objective, what will, okay, how would I say? In the last class, if you, I mean, did you saw this question? I think.
So I haven't attended the last class. Can
Okay.
you please
So
give me the
okay.
link?
Okay, I'll try to. Actually, in the last class, what happened? No, we took one question. Okay, it was something like this, or what step was there? So what was happening is,
This slice.
yeah.
Sorry, sir.
Okay. Just take these two, this one as example. So what will happen? Okay. Here in this case, if we take this point and this point as our initial centroid, okay, it depends on center. So what it means, you know, okay, maybe in this case only, like I'll just try to give you the brief summary. So local minima means just assume that, see, in this question, let's say this is the original data point. I mean the original partition. Okay.
Yes.
Okay, this one was original partition. But in case if I take some other, I mean maybe some other initialization, no, in that case, what we saw is that we got this shape, this one, right? And in one case we got this shape,
Yes.
right?
Yes.
So I think, yeah, I should take the vice example. I mean just opposite example. So let's consider this one as your global minima. Okay.
This picture.
Global minima. Why? Because this is the optimum case here in this case, because if you see the distance of this, if these are the centroids, no, in this case the maximum distance is less than 2 only.
Yes.
Right?
Yes.
So objective function value will be lesser if we compare it from this one. Okay, because here in this case the maximum distance value is 2, right?
Yes.
From here to here. So obviously if we take these two initial point, no, in this case we stuck at some local optima value. Okay, at local minima value.
Yes.
Right? Yeah. So that is there. So you can take it like, see, ultimately there are some groups, but you won't reach at your exact solution. Okay. So that's why we are saying that I mean you may get stuck at local minima. Okay, based on initial.
All initialization might get me a local minimum, but another one might get me the global one.
That is possible. Okay. So 10th question says outliers are data points that deviate significantly from.
Ninth had another statement that the initiation of cluster center may affect the number of iteration k-means take to converge.
Okay. The initialization of cluster centers may affect the number of iteration k-mean takes to converge. So that is also true. Okay. So what happens is that based on your initial cluster center, no, so you may take higher or lesser number of steps to reach to the optimum value of k. I mean, or to optimal, yeah, to the best possible cluster.
Function, right?
Yeah. Yeah. So it depends. For example, in this case, let's see
So
in
we
this
can take
case.
the mathematical way, right? I mean,
Yeah.
the mathematical way statement. Let's say there are k raised to n ways, and if the initialization changes, even if one step is getting less than k raised to n, that means the initialization affects our algorithm. I mean, just like that, you can say that.
Sharon, can you please elaborate this if it's possible, sir?
Yeah. If you want to say that, yeah, you can continue.
I mean, it will be more clear that way.
Okay. Okay.
Sharon?
Should I?
Yes.
Yeah.
So the worst case scenario is k raised to n iterations to converge. So if you have initialization, let's say you have initialized in one way and you're getting k raised to n iterations to converge the algorithm. Let's say you are changing the initialization, the cluster centers at the beginning, and if you get at least one step less than k raised to n, let's say your algorithm converged k raised to n minus 1 steps. So it's not the same for at least one case. So that means the initializations actually matters. If all the cases you are taking, all the initialization process, all the centroid you're taking, and it's converging after k raised to n or on spot k raised to n steps, then initialization doesn't matter. So at least one case means it's not true for all cases. So that means the initialization step matters in that way.
See, let's say, okay, I'll tell you with this example only. So let's say this is our data points, okay, and I took this one and this one as our initial cluster center, okay. In this case, what is happening? What will happen in the next step? What will happen? We will get we will get a group like this, right? In the first step, it will be like this, and then in the next step, it will be something like this, okay. So here it will be, or I may either it may converge at this point, and also if the distance is this, if this distance is very high, no. In that case, let's say here 1, 2, and 20. Okay.
Yes, that is
okay.
true.
Yeah. Okay. And here also like 1, 2. Okay. So in this case, so first step we will get this one, no, and the second step is step 1. Okay. And then in the step 1, what will happen? So these 2 points will be like this only, and since our cluster center will be somewhere here only, then in the second step, what will happen is that these 2 points will fall into this shape. Okay.
Yes.
And this point will be alone, something like this. Okay.
Yes.
Right. So this is going to happen. Okay. Or maybe I should also take one more point. Okay. 20 and again 22. Okay. Just to give you the better idea. Okay. So in this case, if you see what happened, okay. So you took, I mean, if this was your initial cluster center, no? In this case, you took 2 steps to converge. But if I take our cluster center as not these 2, one here and another here somewhere here. So in this case, what you will see, just after one step, your algorithm will converge, right?
Yes, sir, because the cluster center is in
Yeah. Yeah. So this is what this question is saying. The initialization of cluster center may affect the number of iteration. Okay. In this case, I mean, just after the first step, no, you will reach at the, I mean, this one, I mean, the optimum cluster optimum case. Okay.
Because the cluster center in the same group. I mean, in
Yeah,
the
yeah,
nearest distance of
yeah.
the
And I mean, this time we had different initialization. Yeah. And how many? Okay, one more thing. If I talk about the mathematical, so how many cluster? I mean, possibility. How many maximum number of iteration is possible here in this case?
You have 20 points set. How many points?
Actually, no, 6 points.
6 points.
Yeah. So how many maximum number of iteration possible?
6 iteration is.
No, 6 points are there. Then it is like k to the power n. Okay, so k value is 2, 2 to the power 6. Okay, since the see we had two, in other words, I can say that we had two clusters. Sorry, so we have two clusters. So each point has two options. 1, 2. Then again, this point also would have two options. 1, 2, and again another point will also have two options. Right?
So one point had two options. You were saying, right?
Yeah, yeah.
But why two only? I mean, you can get more than two, right?
See, what I am saying. Let's say you have uh, four data points and two boxes. So how many options it has? How many possibilities there for this
Okay, so
point
I
to
got the point.
enroll
Yeah,
in a
it's
cluster?
up to
Okay.
two options. Yeah, we
Yeah.
got two groups, so it's up to two.
Yeah. So that two groups here and here. I mean k. I mean in the formula it is k groups. Okay,
Yes.
and is the number of data points. Okay. So I hope this is clear. So 10th question says outliers are data points that deviate significantly from the rest of the data. Right? I hope you know, I mean I hope you are aware about like what is outliers.
Yes.
Yeah. So knowing the way Lloyd algorithm work, do you think it will affect the? I mean, it will sense the whether the Lloyd's algorithm is sensitive to outliers or not?
Yes, sir. It is sensitive.
Yeah, sensitive because like it is ultimately the distance. Here in the last, I mean, the example which we took just now. So in this case also like we increase the distance. Okay,
20,
and this
20.
yeah, it completely affects it completely affects our assignment. Okay, or our final clusters. Okay, so
Yes.
that was true. Okay, let's move to the question. Yeah. Here I would have. Okay, these questions are just basic questions only. I mean, yeah. So here in question 1, it says that consider the data set in R. Okay, Lloyd's algorithm at k equal to 3 is applied to this data set with initial cluster centers 0, 300, and 310. After convergence, let ABC represent the final cluster centers. So what is the value of A product ABC? Okay, so what do you think? Okay, let's put all the points on one one line. -2, 1, 3, 5, 8. Obviously, 302 will be 2, 308. Okay, let's increase this line also. Okay, so in this case, what we are saying is that okay, so where is our first cluster center at 0? Somewhere here. Second cluster center 300. Third cluster center 310. Okay, so what will happen? Just assign the value in C1, C2, and C3. What all values will be? I mean, what all numbers will fall into this C1 cluster? Can
So
someone say?
1358 minus
Okay,
2 1358.
1358. Right. What about
302
C2?
304.
Sir, I think 8 will fall. No, okay, sir. Okay.
302 304.
Right. So 8 is too much far from 300. No, I mean
Hmm.
it's like 292 points away from 300. Okay. So here 302 and 304. And what about
300.
C3?
308.
308. So
So
now
let's
again
find
we will
that.
have to, yeah, again we will have to calculate the mu1. I mean mu1 1, mu2 1, and mu3 1. What will be the value of mu1?
13 by 5, 50. 1, 2, 3, 4
Okay.
points are there. 11, 16, 17, 15 by 4, sir.
Okay. Let me just write the type. Okay. 3 plus 2, 5. Okay. And what about mu2 dash? it will be like this, and mu3 dash will be just 308 only, right? So
Yes,
the
sir.
question was asking that after convergence, let ABC represent the final cluster center. So again, we will have to check whether these are the final cluster centers or not. Just by shape, also like just by the numbers, we can see that this will be the final cluster center only. Just calculate this. Okay.
Sir, this will not be the final cluster center, sir, because you cannot have both 2 points in your 300s, isn't it, sir? Okay, we'll check, sir.
Yeah. What did it say? It will be no.
Okay.
Yeah.
$308.
Okay. So these cluster centers we have now. Since we have taken 3 cluster centers, so that's why these will be the cluster center. So question says, so this will be the A value, this will be the B value, and this will be the C value. Question asks us to multiply these three things.
Oh, multiply.
Okay. Yeah, just ignore it.
Is it a final cluster center? That's why
Yeah.
someone.
So okay. So if you just recalculate it, do you see any point which is closer to these cluster centers? Any point which is not happy with their their current cluster centers? No, na?
I don't think so.
Yeah, because here also like 304 is like just one step, 1 unit away from 303, and 302 is also one step away from here. And these points that that does not make sense, because like this is too far from. These points are too far from these two cluster centers, right? These 303 and 308. So these will be the final clusters.
Okay, sir.
Okay. Yeah.
This is one example for initialization also, sir. See,
Right.
300s will become one group. Before seeing the question properly, 300s one group. Then these 5 things can be divided into 2 groups. That is also a possible clustering.
Right.
But sir, this 303 is one of the means, and for the data point 308, the mean is 308 only.
Right.
The same. So
Yeah.
that's not moving away,
Anywhere.
right?
Yeah. So that point is not moving, but initially the third cluster center was this 310.
310. Yes. Okay.
Yeah.
So, sir,
Actually, yeah, there should be one point 310 also in this. This is what someone is saying. Or
Required, sir. Why we
Yeah.
require 310? It's only initialization, no?
Yeah. In initialization, so usually what happens, in initialization we take points from this. These points only. Okay, but for these questions completely, here in the question only they have taken that we have to take these points as our initial cluster center. Okay. Okay, so since all the points are not inside this, no?
Yes, sir.
Yeah, then it's okay. Based on the question, this will be our answer. Multiplication of 303, and 308. Okay.
So, sir, in this question, there is no role of this initial cluster centers.
Yeah, there was role, no? Okay, yeah. So initially the role is there. Actually not.
Sir, clustering, sir. C1, C2, C3 is based on
So what he is saying is that even if we do not put these things,
then also we are getting
that
the
only I
final.
told no, sir. Then I can have 2 minus 2 or 3 as one center, and 303 as one center, and 308 as one center. Then it will come correct. But if you have 3 as one and 6 as one and 303 as one, you'll have 3 different type of answer, no?
Right. Yeah. So he is a valid point. So see, there is okay. I also just skip this part. Okay. Yeah. So see, here also initialization will affect, no? Here, if we take 3 center, in the question, if they do not mention that these are the 3 cluster center, so you may take this one, okay, and this one and this one. Okay. In this case, what will happen? -2 and 1 will fall in one shape. Okay. No. The one will not go with the. Okay, something like this, 1 and 3 and 5. Okay, this will be another, and this will be the third one. Something like this.
Okay,
right?
But after it has mentioned after convergence, let ABC represent the final cluster centers. So we hope the ABC should be something which must be representing the
No, it
overall
won't
data.
be there. It won't go there. No.
8
Okay.
will
Okay. Okay.
go
Okay.
to the
Okay. Yeah. Yeah.
200.
Okay. It will. Yeah. So see. In that case, what will happen is that this is your cluster center one. No. Okay. So -2 only. For this one, 135. The cluster center is 3 only, and for this one, it will be somewhere between these two. I mean, closer to 300. Right. So, but these cluster center, I mean, this cluster center got changed. No, I mean, these two won't affect. Okay, only C will affect. Okay, I mean, only C will go to move toward this point, but we won't reach at this solution.
Okay.
Getting my point?
Okay, so like you're mentioning that since the initial cluster centers are given, and based on that, we are assuming that the clusters will be group -2,
Yeah.
1, 3, 5, 8 will be represented in
Yeah,
one group.
yeah. From here only we have to do. No, from here only like we have to do. Based on that only like we calculated na C1, C2, C3. No, like what all point will fall in C1 and what all point will fall in C2 and what all point will fall in C3. Okay.
Okay.
Yeah, so
Had
that
this
is there.
C1, C2, C3 be modified as say 0, 1, 2, then our answer would have been different.
Obviously.
Okay.
If initialization of, I mean, if we here instead of 300, if we take, let's say 5 or 10, something like this, no? Okay, or I mean, maybe some other value, no? In that case, the answer will change. Okay.
Okay. Got it.
Yeah. Okay. So let's move to the next question then. I think. Yeah. So which of the following cluster cannot be obtained as final cluster using Lloyd's algorithm? Assume that Lloyd's algorithm was run on these two datasets with k equal to 2. Okay. So question is that which of the following, following partition is not possible. Okay. So in this type of question, what you have to see is that you have to try to locate the centroid of the different clusters. Okay. And see whether it is possible or not. Okay. So can someone say what is, yeah?
Yes, sir. It
So
will
in
be
this
only
question,
a linear loan, sir. You cannot.
yeah. So one thing is that, I mean, it should be linear. So see, just try to, that is also one approach. Here also, like you can see that if we see the cluster center of this red one would be somewhere here, right? And also the cluster center of this blue one will be also somewhere here only.
Same point.
Yeah. So that is not possible, right?
Correct.
Yeah. So, okay, obviously option A is not possible. Let's move to option B. So here, if you see, is it possible? Can someone say?
Sir, what was the question?
So you have to, which of the following cluster center cannot be obtained as final cluster center using Lloyd's algorithm? Okay.
Here
This,
also,
It is possible.
some points are nearer, no, sir? Like if you from -1, 0, these 2 points will come nearer than this cluster center. Because for this cluster center will be 2.5, that blue line. For blue line, the cluster center is from -1 to 5. So it will be somewhere between 2. Yeah, here it will be there. But this point and 0 and -1, if you take the 0th point here, in blue line, 0th point.
Is it? You are talking about this point or?
Yeah, 2 and 2 same place. Yeah. No, it
But
comes
sir,
it is not possible. This option is not correct.
no, it can
the
come
left
-2 0.1 point is there. That is can be
Here, okay, okay, just go one by one. Okay, then I'll put my. It is possible.
This is 0.
Possible.
No, this can be possible, sir.
This is possible. Okay. Is there anyone who says that it is not possible?
sir,
Yes, I said so.
we have to take in account the leftmost distance from the leftmost data point. Maybe the leftmost data point is nearer to the data points of the red points.
It
I
is
mean,
2
mean of
unit
the red points.
and it is 1 unit. So it is lesser than 3, right? So this point cannot, if, I mean, this is the combination, then obviously this point will also fall into this one. This should be red only. right? Because from here it is 3 unit, and from here it should, I mean, it is lesser than 3,
Okay.
right? Yeah. So then, if we do the calculation, then also this option is not possible. Okay. Yeah. So we were said that, I mean, yeah, this is not possible. That is correct. So what about this one?
Not possible.
It is possible because see yeah, for this one, blue one, the centroid will be somewhere here, and for red one, centroid will be somewhere here. Okay, and yeah, based on this, obviously these two centroids are, I mean, not, I mean, no other point is just contra, I mean, wants to, I mean, move to other cluster center in this case. Okay, so this is possible. Okay, let's see about the dis D. So what about this one? Is it possible or not?
Sir, I think it's
Not possible.
Not possible, sir. So
Not possible.
we have to take we have to draw lines and take the center of it, and it should be a perpendicular line we have to draw. So that time we can find out that it's not possible.
Yeah. So okay. So here, if you see, I mean, the centroid of these points will be somewhere here, and for this one, somewhere, I am assuming that somewhere here. Okay. Okay. I mean, somewhere closer to this one.
I think you can place the centroid within the inner circle, but you have to maintain distance from the red points.
Right. So this is what I am also saying. So again, if we centroid is somewhere here, no, in this case, so there will be multiple points which will fall into the. I mean, see, there are multiple points which is here. If you see about this point, no, this is too far from here, and too close from this one. So obviously, this will fall into this one, no. I mean, these points should be red in color, right? So this combination is also not possible. So I hope all of you got it. Okay. So this combination is also not possible. This partition is also not possible. So only option A, B, and D. In this question, yeah, option A is not possible. Option B is also not possible, and option D is not possible. So the answer would be A, B, and D. Yeah.
Okay, sir.
Because the other question is asking that which of the following cluster cannot be obtained.
So the answers are given at the last. Is it true? That
No,
the
I
answers
think
are given at the
answers
last?
are also not given.
Maybe just if you can just verify once. Maybe they are given.
No, it
They are
is not.
Okay. Okay, I'm sorry.
Okay. Okay, let's move to the question number 3. Question number 3 says, consider a data set in R2 with the following data points. So these many data points are there. You want to perform k-mean clustering with k equal to 3 cluster. Initialize the algorithm using k-mean plus plus initialization. Provide the step for k-means plus plus initialization process to obtain the first 3 centroids. So what will you do? Selecting the first centroid.
Randomly select one first point, sir.
Okay. So option says that select the first. Okay. I think option 2, option 3 and 4.
First option, sir. Selecting the first centroid randomly from the data set. First.
Okay.
And then, no, I'm just first.
First point. Yeah. So this one is true. Yeah.
Then we have to find out various distances between the other points, and we have to take the furthest point as a second maximum distance from the mean of the data. Means selecting the first centroid at the point with the maximum distance.
So see, here. So since this, you know that, I mean, the first point would be randomly selected. Okay.
Yes,
so option 4 and 3 is directly wrong. Okay. So I mean, option 3 and 4 we do not have to look. Let's talk about option 1 and 2. So which says that selecting the first centroid randomly from the data set and then selecting subsequent centroid with equal probability from the remaining data point. So we know that probability is not equal. Probability is different based on the distance. Right?
Yeah.
So I mean, I also said that, I mean, yeah, previously also we discussed that, I mean, the distance should be, I mean, it should be the proportional to the square of the distance. So option 1 is correct. I hope it is clear. Okay. Let's move to the next question then. I think number 4. Okay. Question number 4 says, in a clustering experiment with 80 data points in R2, Lloyd's algorithm with k equal to 3 is executed. Okay. Given that 1 1 1 0 1 0 1 are in the same cluster after convergence, which of the following points is most likely to be in the same cluster? Okay. I hope question is clear to all of you.
Yes, sir. We can find out the centroid of those 4 points and ABCD, whichever is nearest, you can take that
So
as.
see. Why would go for this centroid? See, there are 80 data points and only
80 data
two.
points.
Yeah, 80 data points and only two clusters. Let's say cluster 1 and cluster 2. There can be a number point. For example, let's assume that there are 60 points in this one
Three
and 20 in
clusters,
this.
sir.
3 clusters, no sir.
Three
3
clusters.
clusters.
Okay, I mean, is it 3?
A is
Okay,
equal to
yeah,
3.
sorry, yeah, 3. Okay, let's take it like this. Okay, man, any combination is possible. Okay, 3 clusters. Okay, given that these points falls into the same clusters. Okay, let's assume that in this one only, like all the point falls. So what is the what would happen? I mean, what point from these 4 will fall into this one? All point will fall into this one. See, we do not have any information about this. We do not have any information about this. See, in all cases of k-means, I would first suggest you to, I mean, if you do not understand anything, no, directly first draw the try to plot it in the
0,
chart.
0, 1, 1.
So see, here 1 1. Okay, okay, sorry, 1 1 0 1 1 0 0 0. Okay, so if see, if these 4 points lie into the same cluster, no, then any point between these 4 points will also lie in the same cluster, right?
D.
Yeah. So see, yeah, someone is saying something.
0.5,
Okay,
0.5,
yeah, 0.5, 0.5. Anyone else is also saying something? I mean, some other person. Just
1
try
1
to.
also chances same, no sir. 1 1.1.
1 1 is directly given. 1 1 is directly given, so it will obviously fall into this one only. 0.5, 0.5 also, and any point which is available here, no. Okay, maybe some shape would be there. So any point, see, if these corner cases are covered, no. So anything inside this, no. Okay, it will fall into this circle only, right? Because it is not possible. So let's say, let's say this centroid is on this side, no. Then also, like, if this centroid is, this cluster is somewhere, left to this one, no. Then also, this point cannot be closer to this one. Okay, and if this point are, we have another cluster center on this side, then also it is not possible that any point which is inside this is falling into the different cluster. I hope it is clear, or should I focus more on, should I rephrase my sentences?
No, I think it's clear.
Oh, okay. Okay. So basically what we are saying, that any point which is lying inside this one, no, that will also fall into the same cluster only.
Sir, in my way, I may be wrong, but final result may come correctly in this case at least, because centroid is 0.5, 0.5, and what I meant was which is the nearest to the centroid we have to take. See, 4 points were given. I am taking the average of these 4 points.
Okay. So
centroid. So that answer I am getting is 0.5, 0.5. And
okay.
with all the given A, B, C, D options, I am seeing which is the least to centroid.
Okay, which is the least to the centroid. Okay.
Yeah,
so
that will be 0.5, 0.5 will be the least.
Okay, here in this question, okay. Here in the question, we are also not saying that only the, only one option is correct. So that is, so, by list you will reach at just one option, no? Hope you got it.
No, -1 or -1. It will not come in that one option, no?
Yeah. And see, what he is saying is that, see, he is saying that we will take the mean of all the points, and we will see that whether it's this is possible, or that point will fall into this shape only. So see, this is not possible. So if we assume that the one point is here, second point is here, third point is somewhere. Okay, let's take this 2 points only. Okay, so if some point is somewhere between here and here, no, it is possible that it will fall into this one. It is possible that it may fall into the any point between these two, no. it may fall into some other cluster. Is it possible or not?
So what was the question, sir? Like 2 points are given, they are in the same cluster. And
There is another point somewhere here. Is it possible that this point will fall into some other cluster?
No, we cannot know. So centroid, we have to know.
Centroid? Okay. See, there are. I mean, see, final centroid will
Yeah, it
affect.
can
No.
happen, sir. Correct.
Sir, I
Yeah.
think
Possible. Because you can have a centroid which is both nearer to these two, but will be farther to the what point you are given for the last.
Right. So that's the case. Yeah. Someone else is also saying something. Yeah.
Sir,
I have
also
a
we can
doubt.
consider like convex points. So
Okay.
then also we can easily identify and say it will fall under it.
Okay. Can you elaborate more? Like what you are trying to convey?
In MLF, we have studied.
Yeah, convexity.
So by drawing that, we can say that 0.5, 0.5 definitely will be in this. No need to calculate. The convex points will be collinear.
So see here.
Maybe what she's saying, like that clusters can be considered as like a convex space, like so, like you don't have any holes or anything. Like if you take a cluster, any cluster, so it's essentially what you said in the beginning, like whatever point that comes in between these points, they will come inside the cluster, right?
Okay.
Yeah,
So
so it's
in
the
this
same.
case, so what I'm saying now, again, I'll take one example here. Let's say we have these 2 points. Okay. And also like many points. Okay. I mean, n number of points. Okay. And here also like we have few shapes. Okay. Maybe some draw. Okay. So see, this is possible that these 2 points is falling into another cluster center. And here the point, if we take no, this may fall into some other clusters. This is also possible. Okay, because it will, I mean, only these 2 points are not there in the cluster one, right? There are around, I think, 30 plus points. I mean, what based on our assumption in this case is that there are 30 plus other points like which is falling inside these clusters. Okay, see, ultimately, since here we, I mean, for 2 points we cannot say like this. Here, since we had 4 points, no, so that's why it is for sure that any point, if it is at somewhere at the middle, no, it cannot fall into some other cluster. Maximum possible case is that the distance would be same. Yeah.
I have a doubt. Can I share a
Yeah.
Jamboard?
Yeah. Okay.
Um,
Okay. Just please share.
Whiteboard, I mean.
Okay. Yeah. Jamboard. It's okay. Okay. You have the link.
Just give me some time. So it's actually loading.
Okay. I mean, have you just are you sharing your screen or directly the Jamboard link you have shared? No. I'll open it. Okay.
I
You
have
have not given.
created the board, but I don't know if it's visible. It's visible?
Okay. I mean, your screen. You have not shared your screen. Just give me the access.
Just
Just give me the access. I'll
no,
open
I'm
it.
just let me share the screen instead.
Okay.
So that everyone can see that.
Yeah. Then also like if you give me the access no also then also like I can present it. Okay. Both ways is good.
Now it's
Okay.
visible,
Yeah.
right? So
Yeah. It is loading. Yeah.
I mean, it's visible to you,
Yeah.
right?
It is. Yeah. I hope it is visual for everyone.
Yes, sir.
Yeah.
So let's say these are the. Let me just choose another color. Okay, so where we can choose. Okay, red. And these are the data points. Let us say you mentioned. Okay, so let us say this is one cluster, and
This is
let us say
part of
there
one
is.
bigger cluster. This is not one cluster. This is part of one bigger cluster.
We are
Okay.
taking. Let us say we are taking some other
Okay.
situation.
Okay.
This is one cluster, and just wait. And let us say its centroid is somewhere here. No, let me just. This is the centroid. Now we have. Let's say we have another one here. Let me just change the
Yeah.
centroid. Let me just have centroid here. Yeah, we can have it here as well. Let me just here. Okay.
The centroid could be any of the 4 points, or it could be at the
Yeah.
center. That's the maximum
Yeah.
possibility.
So now let me have wait. So this is our centroid. Mm. This is the area we can enclose. Now let us say we have a point inside here. Let's say at the edge, just at the edge, we have the point. Now there's another centroid, and these are the points. All right. So although it's let's say just within the edge, just within the edge, but it is nearer to this centroid.
Okay.
Yeah, that's what I was saying. So
Yeah.
it is within the enclosed area. We cannot deny that.
Yeah.
But it is actually nearer through this centroid.
Yeah.
Despite being fallen under the area, it is still not the part of the cluster.
Yeah, we are also saying same thing. I mean, it is possible that see this square shape you are drawing, no? I mean, see the distance won't work like that. So distance is something like here if you see that we should go for the circle shape, okay, because it's a Euclidean distance, okay. And second thing is that I'm also saying is that see if some point is lying on this this line, no, this straight line, it can fall into some other circle also. It can fall into some.
Let us say
Hmm.
it's not even falling within it is
We
falling
can, yeah,
under the line, but
okay,
still it is nearer to C. Let
okay.
us
If
assume it is
so,
nearer
see,
to C.
okay.
Deveshji, the question is most likely they are not confirming it. Okay.
Okay. And see, second thing is that see if any point is if you will start seeing the no, if any point is inside this one no, see in that case no, what will happen is that it won't be closer to this one, okay. Because see ultimately and these points are this is part of one bigger cluster, okay. Only these 4 points are not there, okay. So if you see the question, I am getting your point. See, yeah. So that is there. So so what we are trying to see in the question, if you see, if you look closely, then what we have tried to convey is that so already we are saying that these many points. These are the points like which is inside one cluster, inside one bigger cluster. So that and the way we have created question, we have given 80 points. Intentionally, I'm a good number of points so that the distance of these points would not affect that much.
Sir,
Yeah.
Sir,
but if we
even if you consider only these 4 points and they are
Hmm.
forming a cluster,
Hmm.
then we say there is another C that's close by, then the boundary points of this cluster will be close to that also. So there won't be a case like this, right? It won't form a case like this. If
Yeah.
they
Here,
form like
the way,
if they
yeah.
form like a hull, if they form like a hull that like that forms the boundary, then every time there is a point inside, it will be part of that cluster only. There is no chance it can be part of another cluster. Right? Because if there is like another point that's close to that point, then the boundary point will also be close to that point. Right? That's Android. Um,
Got it. Okay.
like say here he marked the C with a green, and like the point that inside that close to C, if that point is close to C, then that boundary, two other boundary points, that will also be close to that green C rather than the center C. That'll be the case every time, right? Even if you consider like just only these 4 points or any points, whenever they are enclosed, whenever they form like a convex hull, every point that's inside them, they will only be part of that cluster. There is no chance another cluster can be close to those points. That's the definition, right? Like even if you define convex, right? Otherwise the clusters will have like a hole within them, right? If you start, then the clusters can have like a hole within them. There is
See, one thing I would say here is that, see, if some point is at this line, no, I mean that edges,
yeah,
you
that
cannot guarantee it.
yeah. If it's at the boundary, then I understand. Like if it's a boundary, then we can have like an equidistant another it can be
Right, right.
equidistant. Yeah, that I
Yeah,
understand. But if it's within the cluster, within the inside that boundary, then it has to be part of that cluster, right? It cannot be
right,
part
right,
yeah.
right. That only. That only is the logic here. See, if any point is at the edges or something somewhere, no, you cannot guarantee. Okay, I mean it can fall into some other cluster also and this cluster also. But if any point is inside this one, no, okay, and that too, I mean that too so many inside this one, no, then in that case it is not possible, because you see here in that case, other edges have to fall. Other edge will also fall into the other circle. Okay, I mean other center. Okay, just try out different examples. Okay, you will find it. Okay, for I mean what I am saying is that, see, if someone point is at the edges, so it is possible that I cannot guarantee it. But if I am saying that these 4 points are part of one cluster and any point, so any point inside this, no, that will be also the part of that cluster only. Okay, yeah. Okay, okay, can you stop sharing your screen, Davis?
Sure, sir. Sure,
Yeah.
sir. I'm sorry.
Okay. Let's move to the next question. I think fourth we had to. So fifth question is again, with respect to Lloyd's algorithm in K-means clustering, indicate the correct statements. Can someone say, okay, the final cluster produced by K-means is sensitive to the initial choice of centroid. Okay, I think multiple times we've seen this one. So this one is correct. The objective function in K-means may settle in a local minimum. Reaching the global minimum is not correct. Okay, this one is also correct. The objective function is K-means will always settle into global minimum. So that is wrong. K-mean plus plus is generally preferred when computation resources are limited and the data set is extensive. What do you think? What's your opinion?
Sir, K++ is
False.
actually
False.
computationally resources you require more, no, sir? Because you have to
Right.
compare with
False.
all the points, then find the proportional.
Agree. So there are two things. So first thing is that you need more computation in K-mean plus plus, and when your data set is very high, no, so there, I mean, it is not possible that 1 or 2 points may affect your final output. Okay. So that is there. Okay. So obviously this is not preferred. Okay. When you have good number of data points. Okay. Or very high number of data points. Using a larger value for K will always result in better cluster quality. Is it true?
No, sir.
No,
Because
sir.
we are having that we have to take
Yeah.
turbo point.
Right.
That will be
So
the
that
best.
is, yeah. So I mean, obviously, once you increase the K value, so obviously function is decreasing. But it is not always true that, I mean, you increase K value and you will you will get the best cluster quality. Okay. In practice, K should be as large as possible. Yeah.
So what you
What is the
just said
difference between E and
just now,
M?
like if the data set is really big, then initialization won't have that much of an effect. Is that what it's
Yeah. So I mean, you see, ultimately initialization also, like they have to do calculation. No, I mean, K plus plus, you see that, I mean, initialization has some calculation. Okay, so I mean that is and so we will just avoid it. What will we? So
no,
what?
I understand that, but I'm asking, like, if the data set is really big, then initialization, I mean, theoretically it will have an effect, right? Even
Yeah. Theoretically, it will have an effect. But see, what I was why I said no. See, if you have very good a big number of data points, okay, in that case, what will happen is that, let's say you had to take 100 iteration, okay, 100 iteration to reach at the certain, I mean, at the optimum number of K, or maybe at the solution, if you have to take 100 steps, 100 iteration to reach at the proper partition or the best partition. In that case, what will happen? Okay, in case you had a good number of data points, no, even in if you do not do K-mean plus plus, no, in that case also, like, it will, this iteration may increase or decrease. Okay, I mean few more or few lesser step you may take, but ultimately you will reach at the, I mean, the solution will be similar only. Okay, or I mean, I can say that if very big number of data points are there, no, I mean very high data points are there, you will get the same solution. Okay, here if you see, no, I mean in the all the questions you saw one thing is that one basic thing was there that you had some limited data points only, like the examples which we considered previously. Okay, we have certain limited number of data points, so that's why k-mean plus plus was, I mean, affecting too much. Okay, I mean the initial initialization was affecting the final model. Okay, got it or not?
Yes, sir.
Yeah.
Yes,
Okay,
sir.
so okay, so F point says in practice k should be as large as possible. Again, this is also wrong. And G point said k-mean.
What is
Yeah.
the difference between E and F?
Using a larger value, yeah, I think yeah, both things are saying same thing only. I mean, just the different way of representing it. Just in F, in E we are saying that using a larger value of k will always result in better cluster quality. So again, here also, like, we know that we should use some optimum value of k. And
So does it say that when compared to smaller value of k, larger value of k will always result in better quality cluster quality? That is, in that case, it is true, no, sir?
again, just repeat it.
No, using a larger value of k will always result in better cluster quality. Does it say that in comparison with smaller value of k, the larger value of k will always, because if you are taking k as one cluster, that is, and instead of that, if we take k is equal to 3, then it is always better to have k as 3 rather than 1, right?
So see, it again depends on the k to k cases. Okay, we know that at the beginning, if you increase the k value, that is good. But after a certain point, if you increase the k value, that is not a
That's why
good
I'm
thing.
saying the difference between the E and F. I feel that it's wrong. I understand, but E, I have a doubt whether it says that in comparison with
Possible. They are saying K as
this
large
might
as
be,
possible.
yeah.
F, F.
No, F is wrong. In practice,
Yeah,
K should be as large as possible.
that is
I'm
wrong.
saying,
That is wrong.
yeah, but
Hmm.
I'm saying the E option, does it say that it is in comparison with K? Say, for example, if K is 1, then all the points will be in one cluster.
Okay, so see, one thing
When
I'll
we
say
compare
here.
that with k is equal to 2 or 3, which is larger than k as 1, then in that case the clusters will have a better quality, right? That is
No,
that
no, no.
what they are
See.
meaning?
No, no, no. Yeah, they are saying that whenever you will increase the k value, you will get the better quality. That is guaranteed. This is what this question is saying. For example,
That's
I'll
not, so
take
then
one.
that should be true, na sir?
No, 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 that is not true. Okay, I'll take one example. For example, you took the some lesser k values. No, I'll take that only. Okay, let's say in a class there are 100 people. Okay, and we are. I mean, we just have in our data set we had just gender part. Okay, here what do you think? I mean, the best cluster quality will be when you will get the best cluster quality when k equal to 2,
2,
right?
yes, correct.
Not k equal to 1, not k equal to 3, or not k equal to 5 or 10, something like that.
Yes, yes,
Okay,
yes.
so in this case you see that, I mean, the best I mean, we are getting the best cluster quality when we had some optimum value of k. It
Yeah.
doesn't matter whether it's a lesser or a greater. Okay, some optimum k value. So here in the sentence specifically mentioned, it is k will always result in, I mean, a larger value of k will always result in better
Always
quality.
result. Okay, okay,
Yeah,
okay.
so
That
that is
always
not.
is okay, fine.
Yeah.
Understood, sir. Yeah.
Should the statement be like this? Within the optimum k value, the larger one always gives the better quality.
Yeah. Again, it's subjective within a optimum k value.
Yeah. So you
Yeah.
got that constraint somewhere. You got to put it in the statement.
Hmm. Okay. Then just to make it correct, this is what you are saying.
Yeah, yeah.
Yeah.
Sir,
Again,
sir, because Radhaji's argument is correct when k value is not given.
okay.
There k value male female 2 are there, then you are saying 3 is not good.
Yeah. So what I am saying is that here in the question, if you see, it question is saying that I mean, see, this is wrong for me. Okay. I mean, okay, we are saying that this is wrong. Okay, because this is saying that K will always result in better quality. Okay, if we
Quality
are
we have to
taking,
define, sir, then actually.
then
And,
quality, see, quality is this one only, like based on domain or based on some, I mean, based on terminology, you can say that in this question, the cluster quality is best when K is 2 in the example, the gender example. Okay. If you think, I
Then
mean,
why should they give both the
domain.
options leading to the same meaning? As E and F are more or less the same, right?
see, ultimately, it's yeah. If you see that, I mean, if you see the statement, yeah, you can say like that. Okay, both of the logic of the, I mean, logic which you apply to check whether the statement E and F are correct or no, that is true. Okay, I mean the logic is same. Okay, we should always go for optimum K value. This is the logic behind these
Sir,
two.
one
Yeah.
small correction, sir. Sir,
Okay.
when we studied last class, what we did is we started with k equal to 1 to k equal to n, and we
Hmm.
drew one graph.
Hmm.
And only that graph we are having now. Which k
Hmm.
is the best k with that graph? We told that n is the k equal to n is the best graph. There is a cluster
No,
called.
no, no, no. K equal to n is the not the best graph.
No, we are not. We have not still taken the penalty, sir.
Okay, we are not taking the penalty also.
Yeah, we
Then
are not
also K
taking
equal to.
penalty.
Okay.
So as per this, the k equal to n will give you that xi minus zi square will be 0.
Minimum objective value. Minimum objective function value.
Yeah,
K
mu
equal to n.
a minus mu I will be 0.
Okay. Okay. K equal to n. Yeah.
Yeah, k equal to n will be 0. That is the best. The error is 0 means that is the best, no, sir. Without
See
taking
that.
considering the penalty. That is the
Okay.
best
Even.
quality,
Okay.
no?
Okay. Okay. See again, this is elbow method, and what they suggest is that when you plot these two things, where the maximum bend is happening, that is the optimum value of, that is the good value of K which you should take in your model.
Yes, sir. Yeah, we'll stop there, sir. Now
Yeah.
that some k is there. Okay.
Hmm.
What Radhaji's argument is, if you take a k which is lesser than that given given k is let you take it as t, k minus t minus 1, t minus 2, t minus 3, these are all smaller than k. So, but when you take t minus 5 compared to t minus 4, t minus 5 will be less in quality than k minus 5, no, sir? T minus 5.
Right. That is true.
So, yeah, that is the argument now, sir. We have
So
to
see.
stick to that argument and
See.
answer a question this.
Okay.
Option F.
Okay, so you are arguing about, so I mean, you are confused about option E or option F? So,
Option E.
okay, okay, option E. Okay, option in E, option C, using a larger value of K will always result. See, we are not talking about this optimum value. I mean, if the question would have mentioned something like that, in some sense, it would mention is that, for example, I mean, he was saying that, I mean, optimal value of K after before optimal value of K. Okay, something like this. Okay, if some term or since just if we directly mention just the optimal value of K, so that also does not, that is very subjective, like what is optimal value here. Okay, but
Maybe
at
that
least
always, if it had not been there,
actually,
then
yeah,
it would have been a correct option.
yeah, and then also like here
Naren, sir?
to make it here to make it correct, actually we have to do two things. First, we have to remove this always.
Remove this always.
Okay, if we remove this always and something related to that optimal value.
Optimal.
Okay, if these two things happens no in this question, then option E may get correct. Option E can be correct. Okay. I hope it is clear. See, ultimately, I am understanding that. Yeah.
Sir, one last, small. It's
Okay.
basic clarification. I'm still not 100% sure what does this word cluster quality means. What is cluster quality means? What is the algebraic expression or
So
mathematical
see,
thing for
cluster.
cluster
See, first thing
quality?
is that, see, cluster quality is something like you can from this term. What you can refer is that. What you can refer is that,
Homogeneous.
yeah, or
Homogeneous thing.
you are able to the cluster quality, the better the homogeneity, the better the cluster quality.
Okay, both the points, homogeneity plus the mean distance from centroid.
Yeah.
Both
So
you have to take
ultimately,
consider.
see, if you taking the homogeneity in the real world, no, the distance will be lesser only. Okay. For example, in the case of gender only, like the homogeneity means boys in one section and girls in one section. Okay. If we are taking gender as a parameter, okay, the distance will be lesser only. For example, if I plot, for example, let's say in the Z here we have gender, here we have their marks. Okay, so something like this only. It will be the shape will be something like this, no? So in this case, these points are homogeneous and these points are homogeneous, right?
Sir, marks and gender, I am not able to understand, sir.
See,
Points.
I am taking one data set where we have two columns, marks and their gender.
Okay.
Okay. Person one, it's like, see, marks, gender. There is person one, his marks is 86, and his gender is, let's say, male. Okay. There is person two, his marks is, her marks is 92, her gender is female. There is person three, his marks again, I think 60, 76. Okay.
86, 86,
Yeah.
another 86 female is there. So where will we
Yeah.
plot that?
So it will be, see, here I'm assuming this one is male or this one is female. So 86 and female. So somewhere here, okay, this is 86 and female, this is 86 and male. Okay. Yeah. So here also, like, see, ultimately there will be two different cluster. If we give this as input to K-means algorithm, it will try to create, two groups. Okay. It is just not, it is nothing but the practice question, assignment question 4. That's a type of shape. Okay.
Yeah, it will be a
But
linear straight line only.
yeah. So see, the best cluster quality will be this one. Okay, like this one is in one part and this one in one part. Okay, and in other word, the best number of cluster would be 2. Okay, okay. If k equal to t is then this is the giving us the best cluster quality, right? If we take k equal to 3, the cluster quality won't be good. Obviously, if we are taking k equal to 3, so there would be a different group. Okay, and obviously in one group, it is possible. There is high possibility that in one group there can be male and female both. Okay, or maybe that will be somewhere based on their marks. Okay, it completely depends on your business context and other things. Okay, and your domain thing. Okay.
Okay, sir. Anyhow,
Yeah.
only we are talking, we are able to only visualize when k equal to 2 or 3. When k is more than 5 or 8 or really large numbers, we'll not be able to visualize properly this particular
Right.
examples.
See, yeah, so that's why we use these things, no? Ultimately, if you see what happens, no, in general, in real world, you just plot it. Okay, for example, you plot it elbow, or you just check k values, different k values, and see, see how much difference it is making. For example, in the elbow also you saw, no? After a certain point, there will be a sudden change in the slope. Okay, so you understood that these are the critical k values. Okay, then you can take those k values which makes more sense to your business. Okay, for example, since multiple times we are talking about this, their students marks only, like let's say we want to sometime what happens, no, you already know that how many group you have to form. For example, let's say I have a class and I want to create 3 groups. Okay, and in the marks also, like we have marks, like there, we have in the data set we have their marks and other things. Okay, then we know that already we know that we are planning to create 3 type of groups. In first, like toppers; second, average; third, below average. Okay, or at least, yeah, not do so good, something like that. Okay, in this case you already know. Maybe we talked about the mail, spammed mail and mail. Okay, there are also, like, let's say, already we know that only 2 type of mails is possible, right? Here I'm not asking to predict whether it's a spam mail or mail, or normal mail, but I'm giving this desired data as an input. So obviously from the from my knowledge, we know that there can be only 2 type of mails, right? Or if you want, yeah. Or in case if I want to just create the mails into different boxes, for example, promotion, announcement, all these things. So then from my domain knowledge, I know that I want to 3 groups, right? So that is there.
Yes, sir. Yes, sir. Yes. Last session also we discussed about domain knowledge.
Right.
Yeah, now I understood.
Yeah. Here in this chapter, in this subject MLT, you are just learning the tools. Okay, what all tools we have. Okay, and in MLP and other courses, you will learn how to use the tool. Okay, how you won't be doing these things. Okay, obviously we have libraries and modules. You just directly import it and directly it will do the same job. Whatever you are doing mathematically here, no, those module will do the same job. Okay, but from your business expertise or from your business knowledge, you have to think whether it's how many key values or other things you have to take. Okay, so that's there. Maybe I should search it. Okay, elbow. Okay, oh, I hope my screen is visible, right?
Yes, it is.
Yeah. Okay, just see, different graphs. Okay, in different cases, different shape you will see. Okay, here let's see this one only. So here you are seeing no different for different k values, it is changing. Okay, but if you see that here we have 2, here we have 3, and here we have 4. So which one you would like to take here? Okay,
4.
It depends.
I will take
4.
4, sir, because the
Yeah.
slope is the maximum up to that point. After
Okay.
that, it is slowing down.
Okay. So, but if you see here, I'm sure if someone is getting this type of shape, no, then definitely the data set will be very simple. Okay. And at least the data set would be smaller. And I think, yeah, it is clearly, it is clearly separable. Okay. This is the term I should use. It is clearly separable. Okay. That's why you are getting very clear graph. Okay. But in case if this is not very clear, no, then you will okay here. People can argue at 4, 5, 6 all points. Okay, or since from here, shape has this has just got distorted. The slope has changed. Okay, but you will see that there are different graphs. Okay, or different cases where these elbow points are not very clear. Okay, for example, I think this one. Okay. Okay, not this one. Okay. Actually, there is one, dummy data set. Okay, toy data set on SQL11, which is nothing but this Irish data set. And in that case, if you see, we know that, since from the domain knowledge, we know that how many species are there. Okay. And based on that, but if you see the this shape, no, this is coming at some other point. It is, you will see that maximum number of, maximum slope. Okay. For example, that if you see that question, no, what happens, no? Let's say you have 3 and 4 both. Okay, and if you see that, at 3 and 4 at both points, you will see, if you see from naked eye, no, the slope is very high at both point 3 and 4. But from business knowledge, from the data set, we know that, 3 or I also forgot, like 4 is the optimum value we should consider. Okay, so that is there. Ultimately, it's all about the domain knowledge. Okay, let's move to the question number 6. Okay, I think we are taking too much. I think how many questions we have? Okay, 8 questions. Okay.
Excuse me, sir.
Yeah.
Option G was incorrect, right?
K means suitable for data set with outliers. Yeah, it is incorrect. So you know that, in the last practice it is sensitive to the outliers. Okay. So yeah, we try to avoid. We should always try to avoid it. Usually, what we do in the real world, yeah.
Sir, if it is not suitable for outliers and noise, then what we should do? We should remove the outliers and noise.
Yeah. It's better to avoid the outliers. See, it depends on the, how much. Okay, usually we should try to avoid it. Okay, for example, by the definition also, like we know that, let's say you have 1,000 data points. Okay, and one outliers only. Okay, just few outliers. So in that case, it's better to avoid it. Okay, so what you will do is that, I mean, in the data set, you will see, you will identify the outliers and just you can directly drop it. Okay, or rescale it. Both you can do. Okay, either the rescale your data set or just avoid those outliers. Okay, just ignore them. Okay, ignoring means just remove them from the data set. Okay, because for example, I mean, there was one question, no, I mean, 1 2 3 4 5, okay, again 6 and 1.300, okay, something like this. In this case, if I ask you to create two graph, I mean, if I give you just to create two cluster, what would be the good one?
1, 2, 3, 4, 5, 6 will be in one cluster and 300 will be in another cluster.
Another cluster. So something like this will happen, right? But ideally, if you see the or maybe, I mean, just to create different group. Okay, let's not take minus one minus. So here, if you see, I mean, from the okay, now we are asking you to create two clusters. So it will be something like this only. But ideally, the best possible, I mean, the our solutions would be something like this. You know, I mean, we our cluster should separate negative points and positive points. Okay, for the sake of homogeneity. Okay, right? So if we remove this outlier, no, then obviously
Then
we
only
will
will be homogeneous.
yeah. Okay, then I mean, it's easy to do this. Okay, it's easy to get at this shape. Okay, so that is there. Okay, but again, I mean, many of you can argue that how do you know that, I mean, we have to separate negative and positive value. So again, as I told you, that it depends on your domain knowledge. Like, I'm assuming that this is the our requirement for this case. Okay, but again, since we know that, I mean, if some number, if we put the 300, no, then the cluster center will be too close to the 300 only. Very close to 300. So any point if is I mean, not very close. 300 will be in another cluster, and all data point will fall into the same cluster only. So ultimately, you didn't do anything. Okay, algorithm didn't work well, right? So that is there. And let's talk about question number 6. It says that in the k-means clustering algorithm, the cluster centroid are updated to minimize the sum of square distance. Okay, this is the formula for mu. Consider a data set of 12 two-dimensional data points. Okay, clustering with k equal to 4 cluster. Okay, these are the data. Okay, these are the cluster points like which got into the different clusters. After the second iteration, which of the following option represents the updated cluster centroid? Mu k for C2 using the provided formula. Is it clear? Question is clear to you? Okay, I'll just explain it. Okay, so question is saying that you have 12 points. Okay, these are the points. Okay, 3, 6, 9. Okay, actually 11 points are only there. Yeah, only 11 points are there. Okay, I think there is some mistake. Okay. Okay, consider a set of 12 dimensional data points. Okay, 11 dimensional data points, and the k-means clustering with k equal to 4 cluster. After the first iteration, I mean, after the first iteration, these are the cluster centers, and these are the data points allotted to these cluster centers. So it says that after the second iteration, what would be the cluster center? What would be the C2 centroid of C2?
C. Answer is C, no, sir. C2 will take the center of 5, 5, 6, 6, 7, 7. Centroid will be 6, 6.
6, 6. Here the centroid will be 9.5, 9.5.
No, but they are only asking for C2, sir.
Okay, I'll just show it. Just give me time. Okay, here it will be here where it will be 3, 5 minus 1 upon 3. Right? Minus 1 upon 3. So here the question is, after the first iteration, we have the following clusters. Okay, but after the second iteration, which of the following? After here after this one iteration, no, we have to do one more iteration. Okay, so if it is converged, no, then this option will be correct. But we have to recheck whether it has got converged or not.
I think it has.
Is it?
Seems like it is. No.
Minus 1 by 3 it is, no? It's C. It's a minus 1 by 3. Okay.
Yes, sir.
So minus 1 by 3, if we see the corner cases, so here from 6, the distance of 3 is 3 only. But distance of 3 from minus 1 by 3, it will be 3 point something, 3.66, right? I mean 3.33 actually, right?
Yes, sir. Yes,
So
sir.
it will just move to this one. Okay. I hope it is clear.
Yes,
So
sir.
if it moved from this one to this one, then we would have a new cluster center. Okay, which is nothing but 3 plus 5, 8, 6, 14, 7, 21. 21 upon 314, which is nothing but I think 5.25, something like this, right? So just reiterate it. Okay. Yeah. There anyone who would like?
So 7 will also move to C3, right?
Yeah. Okay. 7 will move to C3. Okay. So see, after the second iteration, we are not talking about the third iteration.
Okay.
Okay. After, because like in the second iteration, the centroid was 6 only, and here 9.5. From 9.5, it is 2.5 unit away. Okay. Yeah. So that's why it won't move in the second iteration at least. Okay. And maybe in the third iteration, 5.25 is the new centroid. And due to 5.25, what will happen? Again, it is 5.25. So 1.75 only. 7. So, and here, from here, it is like 9.5. It is 2.5 from here, no? So
Yes,
7 won't move.
Yeah, 7 won't move. But
Yeah.
there is no such rule as like only one data point will move.
Yeah. No. There is no rule.
Okay.
There is no rule like that. Okay.
So
Any
as
data
many.
point. Agree.
Okay.
Okay. Let's move to the question number 7. Actually, I'm just trying to be in hurry. Okay. Anyways, I mean, if you have any doubt now, you can ask right now also. And if you just try it yourself, and in case if you find it doubt, you can also post in the discourse. Okay. Or if you are feeling right
So
now, I mean,
will this PDF be shared in the
What is
supplementary?
the
okay,
right
I'll share
answer
it.
to the previous question?
Yeah. Sorry,
What is
just
the
repeat.
right answer to the previous question? We ended up.
We ended up the right answer
Option
of
C.
B. B. B
B.
actually. Yeah. The B is the right answer.
Yeah, that's
So
right.
after the second iteration, which of the following options represent updated cluster centroid for C2? So cluster centroid for C2 is you calculated as 6,6, right?
Yeah. So I mean, currently it is 6,6 in the first
Okay,
iteration.
okay. After it moves out, what is
Yeah.
the okay?
3 will come to this C2. Then we have to calculate on the after the second iteration.
Okay. Yeah.
Okay. Let's see this one.
Hello.
Yeah.
खोल रहा हूँ.
Okay. Can okay. 7 questions is considered 9.
माधुना दीदी, माधुना दीदी.
Okay.
अभी बाहर है माधुन दीदी.
Okay, let me mute him. Okay, I hope he is on mute now. Okay, where we were. Okay, I think here. Okay. I hope my screen is visible again, right?
Yes, sir.
Okay.
Yes, sir.
7 questions says consider 9 data points. So these are the data points. Suppose we aim to form 3 clusters. Okay, these are the 3 clusters. 4, 3, 7. Okay, 9. Okay. Suppose we aim to form 3 clusters using k-means. After the first iteration, these are the allotment to the different clusters. Okay. After the second iteration, to which cluster will this data point 2, 3 be as a reassigned? So okay, here in that question we had to also fix that which point will get reassigned, and here like they have already said that 2, 3 will be reassigned. So what would be the cluster center of this one, C1? So it will 3 plus 1 4 by 2 comma 1.5, right? And for this one it will be 13 upon 3 and 16 upon 3. Okay, 2 3 so he is talking about the point 2 3. So this point 2 3 is if we see the distance of this 2 3 from this point, and if we see the distance of this point, okay, just to, from here Okay. Just cross check the distance of 2 3 from here. Okay. What is the distance of this 2 3 from here? 2 2 0 and 3 comma 1.5 1.5, right? And what about this one? It will be like a 13 comma 3 4 point is nothing but 4.3 minus 2 comma 3 sorry, so I may do some wrong calculations also. Just focus. Okay, so here we can say that from this Android C1, it is just 1.5 unit away. But from here, like it's 1.3 comma 1.66, right? So the distance of this point 2 3 from C1 is closer. Like this 2 3 is closer to C1, right? Okay. You can plot it also and see that it will be closer to C1. Okay, by distance also, like I have seen it. Okay, it is just like 1.5 unit away from this one. Okay, I mean from C1, but from C2 centroid of C2, it should be like something like I mean 1.3 square plus 1.66 square. So it will be nothing but I think somewhere closer to 2 units, right? More than 2 at least. And here it is just around 1.5 only. So it will be assigned to the C1, right? Any confusion? Anything?
Next question, sir.
Yeah. Okay, let's see the question number 8. No. Okay, question number 8 says that consider the two cluster centers mu1 and mu2 corresponding to two cluster two clusters C1 and C2 as shown in the image below. Consider the 4 half spaces. Okay, represented by lines L1, L2, L3, and L4. Okay, these are the half spaces. Okay, where would the data point falling in cluster C1 lie? So where will be the points like which are falling under cluster center C1? What will happen? So obviously,
L3.
yeah. So obviously we have to select the line which is bisecting this mu1 and mu2 line. Okay, mu2 minus mu1. So this is the line which is bisecting it. So any point which is the left side of this L3, no, it will be the in the same cluster C1, right, to the left of L3. So I hope, yeah, that's all. Okay. Anyone has
So
any
where
doubt?
will you upload this PDF in the supplementary content?
Okay, yeah, I'll upload it. Okay.
Will you be doing it today or?
Okay, I'll do it today. Okay, I'll take it. I'll do it today only.
Thank you, sir.
Okay. Okay.
Sir,
All right. Yeah.
Sir, if you can.
Sir, are
Yeah.
the assignments prepared? Sir, are the assignments, practice assignments, are prepared by you?
No. Why? I mean,
No, I just felt like maybe the instructor, different instructors prepare assignments for their students. I just
yeah.
thought.
No. Usually, see what happens. No, I mean, I'll tell you about this practice assignment. Means this one or the practice assignment added into the portal.
No, the practice assignments that we get in our course portal,
Okay.
graded assignments, practice
Okay.
assignments, and all.
So yeah, so usually what happens, I mean, since the first term, in the first term, whoever is the course instructor for the subject, they prepares it. For example, in MLP, in data visualization, in other subject like in MLF also, like I had prepared. Okay, so the week which I handled at that time, I prepared it because like I was there in those courses. I was there in the first term, like when it started. Okay, and also like in MLT also, like when it I think the Ashish sir has taken this MLT course earlier. No, at that time I was there. I was also there in MLT. Yeah, I had created content. Okay, but after that term, I mean, actually this in the term like when this MLT started, at that time I think a few other instructors were there in this course, so they created it. Okay, so that is there.
Sir.
Yeah.
MLT mentors, they are not yet allotted, sir.
Is it?
Yeah. Any idea on that, sir? Mentorship?
Okay, MLT mentorship. I'll check. I do not have idea. Maybe you can contact Mayur. Okay. You can mail him. He will help you on this. Okay, but I think all the mentorship session has started. I'm not sure.
No, man, for
No,
MLT,
sir.
not yet, sir.
Not started.
Okay. Okay.